All right. So in the last session, we were talking about EC2, and we talked about snapshots. We talked about the instances, right? We saw how to launch a Linux instance, and we also talked about volume, snapshots, lifecycle manager, which is for backup. We also talked about security group, elastic IPs. Now today we'll be starting with first we'll see how we can launch a Windows Server instance, and then we'll talk about AMIs. Okay, like how we can create an AMI. Then we'll be talking about what are the different types of instance purchase options. Okay, and what are reserved instances, what are dedicated hosts, okay, what are placement groups. Okay, do you have any question before starting?
No.
Okay, all right, sounds good. Okay, let's start with launching Windows instance. Did you set up your AWS account?
I have one, but I got a new computer and I got a new phone, and the Google Authenticator would no longer work, so I wasn't really sure how to proceed from there. So I don't have one right this second that I can access.
Okay. Okay, no issues. All right. Okay, let's start with on the Windows instance. Okay, so in the last session we talked about AMIs. Okay, we also talked about what are the AMIs which AWS is offering. Like they offer 3 types of operating systems, like Linux, Mac operating system, and Windows, right? And we also talked about the marketplaces, community AMIs which AWS offers. Okay. Yeah, so we are going to launch Windows Server instance, Microsoft Windows Server 2019 base. We are going to choose this AMI. So this AMI will be having the operating system already installed, some kind of packages also installed, some software is already installed, and license already configured in it. So here we'll click on select. Then we'll be choosing the instance type. So let's say we'll go with the free tier one, which comes with 1 core CPU, 1 gig of RAM. Okay, for now we'll not touch any of these settings. Storage will keep it as default 30 gigs. Tag we'll talk later. Now in security group, as we are launching a Windows Server instance, so to remotely log into a Windows Server instance, we use port 3389. Okay, port 3389 is the RDP port. Okay, in the certification exam, they can ask commonly used port, like port or SSH port, which is 22, RDP, which is 3389. Okay, MySQL port 3306. Okay, later as we move ahead, we'll talk more about some other ports of different services. Okay, so here we are creating a security group. Let's say my Windows security group. Okay, and then let us allow it to, let's say, my IP. Okay, so here it will be allowed to my IP address. So only I will be able to make an RDP request. Okay, I'll be able to make a RDP request to the instance which will be launched. And review and launch and launch. Okay, here we create a new key pair. Let's say my Windows RDP key.
Kudosh?
Yes.
Do you have to create a new key pair for every instance that you spin up?
No, we can use the same key pair also. We can use if we have an existing key pair, so we can use that also.
But you just have to like assign it to one that exists or create one. Okay.
Exactly. Then we click on launch instances. Okay, also we can assign the same security group also. to multiple instances. Okay, same as key pair. We can attach. We can use. Let's say we have two instances, and we have launched one instance with, let's say, security group 1. So we can launch another instance with the same security group, and same key pair as well. Yeah.
Is there a limit as to how many instances can be assigned to a security group?
Yeah. I think we discussed in the last session, which is 8.
Oh,
We
that's
can
right.
attach 8 security groups to an instance. Okay, so the Windows instance is now in running state. Okay, in the last session we launched the Linux instance, and when we tried to connect to the instance, I mean, just after 15, 20, 16 seconds, I mean, the instance was provisioned and we were able to log into the instance. Okay, after just 10, 15 minutes, sorry, 10, 15 seconds. Whereas for a Windows server instance, it takes at least 4 minutes to provision. Okay, and the way to log into the Windows server instance is also different. Like for a Linux server, we were using terminal, right? We were using terminal to do SSH, right? Whereas for connecting to a Windows server, we use RDP. Have you connected to a Windows server instance before?
No, I haven't.
Okay, so for connecting to a Windows server instance, uh, okay, we use RDP for Windows, we use SSH for Linux. Now to connect to a Linux instance, we need the instance public IP, then we need the username and the private key to log into the instance, right? And we need a SSH client. In our case, we had terminal, right? If you are in a Windows machine, in that case, we use PuTTY to log into the instance. Okay, this is for connecting to a Linux instance. For Windows instance, we need public IP, username, and password. Here we need password. We don't need the private key here. And we need a RDP client, like Remina in Ubuntu, or I would say in Linux. And in Windows, we have remote desktop connection. Okay, it is also a client software, and in Mac, we need to install, let's say, RDP client. The software name itself is RDP client. So right now I'm in a Linux machine. So in Linux, we have Remina. Okay, it is just a software through which we can connect remotely to a Windows server. Now, if we see the requirement, so the requirement says that we need public IP, username, and password. Okay, but we don't have the password. We have the private key, right? So password is generated. Okay, we need to generate the password, and it will be generated from the console itself. So we'll just choose this instance. Then we'll click on connect. Then the second option, which says RDP client. Now here you'll find it says get password. So when we click on get password, it will ask us to upload our key pair. So this is the key pair which we created at the time of launching the instance. So it is basically asking us to upload it here. Okay, and this key pair is basically encrypted. So once we will be uploading it here, AWS will be decrypting it, and when it is decrypted, it will generate a password. Okay, this is the key pair. And here we'll click on decrypt password. And this is the password generated. So why this password will be able to log into the instance. In Windows, the default user is administrator. Okay, so now we have the password, we have the username, and we have the IP address. Okay, we can connect by IP address or by DNS name also. Okay, let's connect with the DNS name. So we'll just copy this and we will open the desktop, RDP client. Let's say in Windows Linux, we have Remina. And here we'll just create a session. So here in server, we have to give the server public IP or the DNS name. Then the username, which is administrator. In Windows Server, the default user is administrator, and then the password. Okay, and then we'll choose here client use, client resolution. These settings will depend on which RDP client you are using. Okay, there are multiple types, different types of RDP clients. So we have provided the server DNS name, or you can provide the public IP, username, and password. Now here we click on save and connect. So first time it will ask you to accept the certificate. So here we'll just, it's basically for host verification. So here we'll just click on yes. Okay, so we are logged into the Windows Server instance. Okay, and here we'll just go to Server Manager just to see the resources. Okay, so in Windows Server, basically we have the Server Manager, okay, through which we can install. Let's say we want to set up install any software, which Active Directory or ISTC server, FTP. So those things basically we can set up through the Server Manager. Okay, it's very easy to use. It's just by few clicks we can set up the server. Okay, let's say it has 1 GB of RAM. As we use T2.micro, so it has 1 GB of RAM, 1 core CPU, 30 gigs of storage, right? And the operating system is Microsoft Windows Server 2019 Data Center Edition. Okay, here you can see that 30 gigs of storage. Do you have any questions still here?
Nope.
Okay.
Dave, car keys?
Okay, now let's say at the time of launching the instance, we want to install some softwares, or we want to add some users inside the instance, or any kind of automation we want to perform at the time of launching the instance. Okay, so we have EC2 metadata. Okay, let's say we are launching a Linux instance and we want to install, we want to create a user when this instance will be launched. Okay, or any kind of software we want to install. So here basically we have EC2 user data, sorry, metadata. Sorry, there are two things. One is metadata and user data. Are you aware about metadata?
What's that?
Metadata.
Oh, I guess that's just information about the server.
Yeah, exactly. Metadata, yeah, in EC2 we can say information about the server or instance, but in general, it is basically information about any resource. Okay, it can be any resource. Let's say there is a file. So if we talk about metadata of a file, so the metadata of file will be like when the file was created, what is the file size, what is the file name, who is the owner of that file, when the file was modified. Okay, that will be the metadata. So in EC2 also we have two things. One is metadata and one is user data. Okay, so metadata will basically give us, it is basically a API. Okay, it is basically a EC2 API by which we can get instance details. Okay, instant details or instance metadata. Okay, like, okay, so for example, like public IP, AMI, private IP. Okay, what security group instance is using. Okay, this information basically we can get by metadata. Okay, there is an API, EC2 API. EC2 metadata API. Yeah, and this is the URL. This is the URL of that API. Okay, this can be asked in the certification exam. They will give you what is the out of the, I mean, what is the correct EC2 metadata URL, okay, or API. So they will give you 4 options. Okay, and this is the I would say this is the endpoint, metadata endpoint, which has this IP address, then latest API, and then token. Okay, so mainly you have to just remember this IP address. It is 169.254, and then this part is basically repeated again at the end. 169.254, 169.254, 169.254. Okay, and how we query this API? We query this API by curl. Okay, we query this API by curl. Okay, and metadata is data of data. Okay, do you have any question in about metadata?
See the internet first for just a second there. I'm not sure if you explained this, but so that address there with the slash token, is that where you're meant to put some sort of token?
Yeah, actually, one second. Let's say when we launch the instance, by default it is enabled. We have to, there are 2 settings whether to enable or disable it. By default it is enabled. Okay, currently I'm using one security group which already existed in the account, which has port 22 open and open to all IPs. And let's say we want to use the same key pair which we use for the Windows instance. Here we are using the same key pair. Okay, so the instance is running. Now we can connect to the instance. So we'll just copy the public IP. Then we'll try to SSH to the instance. So we'll go to the downloads directory where the key will be is downloaded. And then we'll run chmod 400 and the key pair name. And then we'll do SSH ec2-user and the public IP and the key pair. Oops, it says permission denied. ec2-user. Okay, that is the right key pair. I already have one key in my machine. Windows RDS key pair. Okay, so we are logged into the EC2 instance. And now now let's see how we can query the metadata. Okay, so we just need to call HTTP 169.254.169.254. Okay, then slash API. Actually, one second. Yeah, slash latest slash API slash token. Slash latest slash API slash token. Okay, it says not found. Okay, then latest, then metadata. Yeah. Yeah, so this is the URL https http 169.254.169.254 slash latest slash metadata. And here we can see what information, yeah, these are the metadata which we can get for the instance. Let's say we want to see what is the instance ID. So here, just after that, we will add instance -ID. That's it. And this is the instance ID. Let's say we want to see the security group. So here we'll just replace instance with security group. So here you can see the security group name. Okay. Let's say we want to get the public IP. So this is the public IP. Okay. Do you have any question on metadata?
Nope, that's really cool.
So the same metadata we can get, basically we can get for both actually Linux and Windows both. Okay. And just we need to remember this IP address because in the certification exam they will be actually asking this endpoint only, this IP address, which is 169.254.169.254. And we can query it using curl command line utility. Okay, curl is basically a Linux command to query a URL. So here also we used curl only, curl and then the URL. Now let us talk about user data. Do you have any idea about user data?
I think that you can put scripts here.
Yes, exactly. Here we can put scripts. Let's say for Linux, we can add shell script, shell or bash script. Okay. Whereas for Windows, we can add PowerShell script. Okay, and this script will be like automating some tasks. Like let's say it will be installing some packages, installing some software, adding some users. Okay, it will be basically configuring an environment. Okay, so let's say you want to launch 5 instances, and you want to, after launching those instances, you want to create, let's say, a user account for your dev user. Okay, dev user, to give dev user access to the EC2 instance. So in that case, basically, we can just create a shell script, and in that shell script, we can just write, let's say, the commands to add a user. And when the instance will be launched, let's say 5 instances will be launched, the user data script will be executed in each of the instances, and user will be created inside the instance. Okay, any kind of automation basically we can do with user data. Okay, also one more term basically which is used with user data is bootstrapping. Okay, one more term which is commonly used when we are talking about user data is bootstrapping. Okay, it is like pre-configuring the server. It is basically making the server ready to use. Okay, for a specific task. Let's say we want to run application inside the instance. So we can bootstrap it with the user data. We can write a script that will be installing the software inside the EC2 instance. So for Linux operating system, we use shell script, bash script, whereas for Windows, we use PowerShell script. Okay. Do you have any question on user data?
So user data is where you put their scripts. Okay, and it's typically used to install packages and configure your environment.
Not only packages, anything we can do, anything which we want to do after launching the instance. Okay. We can do at the time of launching the instance via user data. So we don't have to manually log into the instance and run those commands. User data will automatically run the script inside the server.
And this runs whenever the server is started?
Yeah, whenever the server is in running state. And it is only executed once at the time of deploying the server. After that, it is not executed. Okay, it is only
if you were to restart the instance, would it execute
it will not be
upon being restarted?
No, it will not be executed. It is only executed the first time when we launch the instance. Okay, do you have any question in metadata user data?
Nope.
Okay, sounds good. Okay, now let us see how we can create an AMI. Okay, we already discussed in the last session what is an AMI, which is basically an operating system image, which already has the operating system installed, some software is already installed, right? Now let us see how we can create our own AMI. So for creating an AMI, first we need a base image. Okay. For creating an AMI, we first need a base image. Let's say in AMI we have we need a first we need a base image. Okay, base image, or in AWS terminology we can say a base AMI. With that base AMI, we launch one instance. Okay, first we need a base image. With that base image, we'll launch an EC2 instance. And in that instance, we will install softwares or whatever configuration we want. In that instance, we will install the softwares code or whatever we want to install. And after that, we create the image. We create the AMI of the instance, AMI of the running instance, we can say. Okay. So first we need the base AMI. So using the base AMI, we'll launch the instance. And with that instance, in that instance, we'll install some software or configuration, anything we'll do. And after that, we'll create an AMI of that. And when we'll be launching an instance using this AMI, which is created through this process, so that AMI will be having all these things. It will be having, let's say, the operating system, which is coming from the base AMI. Okay. It will be having all the softwares. Let's say we have installed here, let's say HTTPD, which is the Apache Web Server software. So it will be having the Apache Web Server software already installed, or also any other configuration which we have done inside the instance. It will be having all that configuration. So the new instance which will be launched by this AMI will be having all this, all the configuration which we did for this server before creating the AMI. Okay.
So would it be safe to say that it's a copy of the instance?
Yeah, it is a kind of, we can call it as a copy of an instance.
Is
And
there
with
anything
that copy,
that's
we
lost?
can create more instances. No,
Okay.
no data is lost.
Okay. If you were to, let's say you wanted to move a server into a different AWS account, which I don't know if that's possible. So you just wanted to make a copy and then spin it up with the AMI. Would that be a use case for that? You could just, you wouldn't lose anything.
Yeah, actually, there are a lot of use cases where we can use this AMI. So let's say when we have created this AMI, so then let's say this is our custom AMI, which we have customized and installed some softwares in it. Now with this custom AMI, we can transfer, or we can say we can migrate an instance from one region to another region. Okay, we can also migrate, or we can say we can also share an AMI privately with other AWS accounts. Okay, we can also share an AMI privately with other AWS account. We can also make an AMI publicly accessible. Okay, we can also make an AMI publicly accessible, which will fall under community AMIs. Which will fall under community AMIs, right? Like when we launch the instance, so here we have community AMIs. So let's say if we create an AMI and if we make that AMI public, then it will be listed here in community AMI. If we make it public, if we share with some other AWS account, then it will be here. You will be able to see an option. Yeah, here you can see shared with me. So you'll be able to see all the AMIs which are shared with this AWS account. Okay. Okay, to create an AMI, so let's say we launched one Windows Server instance. So let's say in this Windows Server instance, we'll just install, let's say, Google Chrome. Google Chrome is by default not installed in a Windows Server instance, and that is actually, I would say, mostly used for surfing, right? So what we'll do is we'll install Windows server, Google Chrome in this server, and after that we'll create an AMI. So then the next time, instead of using this base AMI, okay, this AMI which doesn't have some software installed, instead of using this AMI, we will be using the custom AMI, which we have created by already by installing some softwares in it, right? When we launch an instance with that AMI, it will be having, or it will be already having that software, let's say Google Chrome already installed in it. Okay, so we don't have to do the installation every time. Okay, also first we need to disable one security setting in Internet Explorer, which basically restrict access to accessing many of the websites. And then in Google Chrome, we'll just search for, Internet Explorer will search for Google Chrome. Okay, so here we click on download Chrome. Okay, it's downloaded, then we click on run. Okay, so Google Chrome is installed, and we should see, yeah, so it is installed. Now what we'll do is we'll just close all of this, and now we'll create an AMI. Okay, so I'll just log out from this server, and we'll go to the AWS console, and we'll go to the instances. Okay, so this is our Windows server. So we basically launched an instance, right? First we launched an instance with an AMI. So that was a base AMI. So then we launched, using that base AMI, we launched an instance. And in that instance, we installed one software, which is Google Chrome. Okay. Now what we are doing, it could be any software. Okay. Just for example, I have installed Google Chrome. After that, we just need to right click here on the instance. Then we'll go to images and template. And here you will find create image option. So here we'll just click on create image. Then you can give a name here of to the image. Let's say Windows Server with Google Chrome. And then create. If you want, you can attach more disk storage, or if you want to increase the disk storage, that also we can do it from here. Then create image. Okay, it's just a very easy process. We just need to right click on it, images, and create image. Now if we go to AMIs, so we should see an AMI creation under process. Yeah, here you can see it is in pending state. Now depending on the size of the AMI, size of the, I would say, the storage, the volume which is attached to the instance, depending on that it will take some time. Okay, so this is of 30 GB, so it may take 10-15 minutes to create the AMI. Okay, so depending on the size, it will take some time. So let's say if it would be a 1 terabyte disk, then it would take almost, I would say, 4-5 hours to create it. Okay, it is still under pending state. Okay, once it is created, the status will be changed to available. And after that, basically we can, yeah, here you can find modify image permission. And with this, basically we can share this AMI with a, let's say we want to share it to some other AWS account. So we need to provide here just the AMI ID here. Oh, sorry, the account ID here. And the account ID basically we can get from here. So we need the account ID of the requester account. Let's say we want to give access to some other AWS account to this AMI. So we just need to give here that AWS account ID here. Okay. Or let's say if you want to share it publicly, so we can make it publicly accessible. And once we make it publicly accessible, it will be accessible. It will be available in the community AMIs. Okay, after that, anyone who has an AWS account can search for our AMI and launch an instance using that AMI. Okay. By default, it is set to private, and it is by default only accessible to our AWS account. Okay. And once it will be created. Once it will be created, so we will be able to see it in my AMIs. Okay, right now it is still under creation. Okay, once it is created, then we'll be able to see here it in my AMIs. Okay. Once it will be created, we'll be able to see it. Yeah, it is created now. And actually here in the console also, we will be able to see it in available state. So if we go to AMIs, Yeah, the status is available. And once the status is available, we are able to see it here. Okay, we are able to see it here, Windows Server with Google Chrome. Now, when we will be launching an instance with this AMI, that instance will be having Google Chrome already installed in it. Okay, and currently the AMI is private and it is only accessible to our AWS account. And we can share the AMI to some other AWS account also, and we can also make it public also. Once we make it public, it will be listed here in community AMIs, right? Do you have any questions still here?
No.
Okay, we can also copy an AMI. We can also copy an AMI to some other region also. Right now, let's say we have created the AMI in Virginia. Now, let's say we want to use this AMI in some other region. Okay, also one more thing to note here is AMIs are region specific. Okay, so let's say the AMIs which you have in Virginia, you may not have those AMIs in some other regions. Okay, mostly all the AMIs you will be able to see the basic AMIs like Amazon Linux, CentOS, Red Hat. You'll find that on all the regions. But let's say the community AMIs, you'll find in some specific regions only. Okay, so that's why we have this option of copying the AMI to some other region. So with this, basically, we can copy our AMI to some other region. Okay, and then in that specific region, we will be able to launch the EC2 instance, right? Okay, and usually we create the AMIs of the root volume only. Okay, usually we create the AMI of root volume only. Root volume where the operating system is installed, right? Where the operating system is installed. If we create, let's say, of a data volume where data is stored, so we'll be able to create it, but with that we'll not be able to launch a EC2 instance, right? We'll not be able to launch a EC2 instance, or we'll not be able to connect to that EC2 instance. And to delete an AMI, we just need to deregister it. Okay, once we deregister it, it is deleted. We can also create an AMI. We can also create an AMI by snapshots. Okay, with snapshots also we can create an AMI. And with volumes, we can only create snapshots. Okay, with volumes, we can only create snapshot, whereas with snapshots, we can also create, we can create both. We can create volume also and AMIs also with snapshot. Okay, let's say this is the snapshot we created of our EC2 instance. And of this snapshot, then we can create an AMI. We can create an AMI. Okay, also when we create an AMI, a snapshot is also created. Okay, when we create an AMI, a snapshot is also created. So this is the snapshot which is created by that AMI. Okay, the snapshot here we are seeing is of that AMI. Okay. Okay, now let us talk about instance types. Do you have any question till here about Windows or Linux servers?
No.
Okay, now let us talk about instance purchasing option. Okay, now let us talk about instance purchasing option. So when we launch an instance, okay, so right now the instance which we used to launch, we used to pay an hourly charge. Okay, there is an hourly rate applied on that instance. Okay, so that instance is basically called a on-demand instance. Okay, that is basically called a on-demand instance. Okay, there are three types of purchasing option. One is on-demand, one is reserved, and one is spot. Okay, on-demand instance, reserved instance, and spot instance. What is the on-demand instance? And in on-demand, basically we pay an hourly charge. First, let us talk about in terms of pricing. In on-demand, basically we pay an hourly charge. Okay, we pay an hourly charge. Whereas in the reserved instance, we have to pay a charge of 1 year or 3 year. We basically purchase an instance here. Okay, in this case, in reserved instance, basically we purchase an instance. Okay, this is basically all about purchasing the instance. Okay, there is no difference between on-demand instance, reserved instance, or spot instance in terms of server configuration and performance. The only thing difference is of pricing and use case. Okay, so in on-demand we pay an hourly charge. In reserved instance we pay yearly. Okay, yearly of 1 year. Basically we have two ways to do that. One is yearly payment, or 1 year payment, or 3 year payments. Yeah, 1 year or 3 year payment. And there are 3 payment options available. One is all upfront, no upfront, and partial upfront. Okay, we have 3 options available. One is all upfront, no upfront, and partial upfront. Okay, so we have reserved instance which we purchase for 1 to 3 years. Okay, then we have spot instance. In spot instance, basically we have to bid a price. Okay, we have to bid a price, and this price is basically decided by AWS. Okay, this price is basically decided by AWS. Okay, if we compare all these EC2 instances in terms of pricing, okay, compare in terms of pricing, in terms of, like, if we see which is cheap, so spot instance is the cheapest. Spot instance is the cheapest. Okay, spot instance is the cheapest. Here we have to just bid a price, and that bidding price is cheap as compared to the hourly rate. Okay, which is cheap as compared to the hourly rate and the reserved instance rate. Okay, so spot instance is the cheapest. Now let us talk about a reserved instance. So reserved instance is cheap as compared to on-demand instance. So it is basically cheap if we compare it in with on-demand instance. Okay, it is cheap than on-demand instance. Okay, in on-demand we have to pay an hourly charge, where we have to pay for basically for a long term, for 1 year or 3 year. Okay, and the rates are cheap as compared to this hourly charge. Okay, so this on-demand is the, I would say, most expensive. Okay, then we have reserved instance, which is basically cheap as compared to on-demand instance. And also the selection of these instance purchasing, it completely depends upon the use case. Okay, now let's talk about use case. In which use case we'll be using what instance. So now let's say we want to run staging environment, staging or development environment. Okay, and we want to run it for let's say we want to run it for 3 months, or let's say we want to run it for a short period of time, less than a year. Okay, let's say we want to run it for 3 years or 9 months. Okay, or I would say we want to run it less than a year. Okay, if you want to run the instance less than a year, plus if you are not sure about your compute needs. Okay, in this case, if you want to run it for less than a year, plus if you're not sure about your compute needs. What are compute needs? What will be the CPU, how much CPU we need, what will be the RAM we'll be needing. Okay, let's say if the application is currently in the development stage and we are not sure about what resources it will be consuming. Okay, so in on-demand instance, we can change the instance type. We can change the instance type. What is instance type? Instance type is that t2.micro, t2.medium. So in on-demand, we can change the instance type. This is only possible in on-demand instance. We cannot change the instance type in reserved instance. We cannot change the instance type in spot instance. Let's say we have purchased a reserved instance, and after that we have to change the instance type. Let's say as the traffic grows, we want to change the instance type. So that is not possible in reserved instance, and it's not possible in spot instance. Okay, so that flexibility basically we get in on-demand instance. Plus, if you are going to run your application less than a year, okay, let's say you want to run dev environment, staging environment, and you want to run less than a year. In that case, you can go with on-demand instances. Okay, now reserved instance. Do you know how to change the instance type?
So just put that.
Yeah, I think you just go into the GUI and I think, do you have to stop the server?
Yeah, we need to stop the server, and then basically we'll find an option of change instance type. Okay, right now this is terminated. Okay, also let's say when you are launching the instance, if you scroll all over down in instance detail, you will find purchasing option, which is set to on demand, which means this instance will be having an hourly rate. Okay, also if you go to the third option where we choose configure instance. So here basically we have purchasing option. From here we can request spot instance. Okay, and depending on the instance type we have chosen in step 2, let's say if we choose t2.micro, let's say with 1 core CPU, 1 GB RAM. So here, depending on that instance type, we'll be able to see the bid price. Okay, this is the bid price. Okay, this is basically showing off all availability zone. This is the current price. Okay, and this price is decided by AWS, and every day it keeps on changing. Okay, not every day, I would say every hour it keeps on changing. Okay, and this is decided by AWS. It is basically decided based on the number of vacant servers they have in the data center. Okay, depending on the vacant servers they have in the data center, depending on that, basically they set the bid price, and this bid price is very cheap as compared to the on-demand price, which is the hourly rate. Okay, this is very cheap as compared to that on-demand price. So here basically we have to bid a price. Now let's say we want to run the instance, let's say for 1 week. So we can just multiply this with the number of hours in 1 week, and that bid price we can put it here. Okay, that bid price we can put it here. Okay, yeah, that bid price basically we can put it here, and for that period of time we can say we'll be the owner of that instance of that period of time. And let's say if the demand increases, so 2 minutes before, AWS will basically send us an alert that the price of the instance is high now, and then they will basically ask us to purchase at that specific rate. If we agree to purchase at that rate, then AWS will keep that server running. If we do not agree to purchase on that rate, then AWS will terminate the instance. Okay, in that case, AWS will terminate the instance. And changing the instance type is only available in Linux server. Oh, sorry, only available in on-demand instances. Reserved instance, we cannot change the instance type, nor for spot instances. We cannot change the instance type after launching the instance. Okay, now the instance is in running state. Now to change the instance type, we just need to stop the instance. Okay, confirm that you want to stop. Yes. So first we need to stop the instance. Okay, and then from here we can change the instance type. T2.micro, T2.small, T2.xlarge. Okay, let's say we want to change it to T2.small. Then apply, and then we can start the instance. And the instance type is changed. So this is only possible for on-demand instances. This is not possible for reserved instances or spot instances. Okay. Also, when we stop the instance, if the instance is stopped, so we are not charged for that instance. Are you aware about that?
Yes, so with on demand, you're only charged while the server is running.
Yeah, we are only charged when the server is there. Okay, so if we are not sure about our compute needs, plus we are not, if we are going to run the server for less than a year, in that case, basically we go with on-demand instance, where we have to pay an hourly charge. Now let's say we are sure we are sure about the compute needs and we want to run the server, run the instance on AWS for at least 1 year, or 3 years. Okay, if we are sure about our compute needs, like let's say we are only going to use T2.medium for a year. Okay, in that case, we can go with reserved instances. And reserved instances are very cheap as compared to on-demand instance. Here in a reserved instance, we don't have to pay the hourly charge. But here we have to pay, we have to purchase the instance for a year or 3 years. And here we have to pay the charges, let's say in all upfront, no upfront, and partial upfront. Okay, this is the pricing model which is in reserved instance. So to purchase a reserved instance, if we go to the console, so here you'll find reserved instances. Then here we'll click on purchase reserved instance. Then here we have to choose the operating system, then offering class, instance type. Okay, let's say we want to purchase a T3.medium instance and we want to purchase it for, yeah, here you can find for 1 year or 3 years. Let's say you want to purchase for 1 year, and then payment option, all upfront, partial upfront, and no upfront. So let's say search. So it will basically show us the pricing models. Okay, and let's say offering class, let's say standard. Okay, yeah, here you can see, let's say we want to purchase for a year, and payment option we have set to any, and we want to purchase T3 medium instance. So here you can see upfront price. If we are going to purchase upfront, like let's say we purchase upfront. So this billing will go to our AWS account. First, we have to pay the bill, and after that, this reserved instance will be activated in our AWS account. Okay, if we go with upfront, and if we go with no upfront, okay, here you can see payment option all upfront, no upfront. If we go with no upfront, then we have to pay an hourly rate, and this hourly rate is cheap as compared to on-demand instance. Okay, this hourly rate is cheap as compared to on-demand instance. Then partial upfront. Partial upfront is like 50% now, and 50% will be the hourly rate. So once you buy all partial upfront, so first you have to pay the 50% price, and after that, an hourly rate is applied to the instance, which is very cheap as compared to on-demand instances. So if you are going to purchase, if you want to run your workloads, you want to run your application on AWS for a longer period of time, and if you are sure about your compute needs, in that case, we use reserved instance. Do you have any questions still here about reserved instances?
Does each type have, what was it, the offering class, or is it only reserved instances that have the offering class?
Offering class, basically we have two types. One is standard and convertible. Standard is basically if you are using standard, then we cannot sell the reserved instance. We can also sell the reserved instance. Let's say later we don't want to use the reserved instance. After 6 months, let's say we the plan is changed and we are not using, we don't want to use the reserved instance. So if it is of standard, so we'll not be able to sell it. But let's say if it is convertible, then we'll be able to sell that instance. Okay, but if we purchase of convertible is little expensive as compared to the standard class, but it is cheap as compared to the on-demand price. Yeah. Make sense?
Sure. Is the offering class, are you able to choose that for on demand, or is it only for reserved?
It's for on-demand.
The
Oh,
offering class?
sorry. Offering class is only for reserved instances.
Okay, thank you.
Okay, now let us talk about spot instances. So we already saw in spot instance, basically AWS decides the bid price. The bid price. And again, bid price is basically an hourly rate. Hourly rate, which is very cheap, as compared to reserved instance and on-demand instance. Okay. And when we use, what is the use case of using spot instance? When we want to perform testing. Okay, when we have to perform testing, and that testing will require a lot of resources. Like it will require M5 instance, which are, let's say, 32 core CPU, 128 gigabytes of RAM. And let's say if we launch it for as an on-demand instance, so in that case we have to pay $5 or $6 an hour, right? But with spot instance, with that bidding price, we have to pay almost 60% less as compared to the on-demand hourly charge. So when we have to perform testing, in that case, usually we use spot instance. Okay, and this is only for, let's say, when we have to perform testing, and this is, and actually bid price keeps on changing. Let's say if you purchased an instance, let's say at 5 cents. Okay, let's say purchase an instance for 5 cents. So later, let's say after 2 hours, if the price changed from 5 cents to 7 cents, so AWS will basically send you an email asking you to purchase the instance at that price, at that 0.7 cents. If you agree, so the instance will keep on running. You'll be able to use that instance. If we deny it, so AWS will instantly terminate the instance. No, AWS will give us 2 minutes, and after that it will terminate the instance. Okay, so spot instances are very cheap. Okay, and it's only used for testing purpose. Or let's say you want to run some kind of batch processing, which require a lot of resources. Okay, which require a lot of servers and a lot of resources. In that case, you can use spot instances, okay, which are cheap. So in this, basically on-demand, reserved, and spot instance, so the major difference is only of pricing. Okay, pricing, and choosing these pricing model completely depends upon the use case. Okay, do you have any question till here?
Yes, so for the spot instance, in theory, if you were to continue replying yes, I agree to the pricing change within the 2 minutes, could that server run continuously?
Yeah,
Okay.
Exactly.
But if you miss an email or you don't respond in time, they'll shut the server down, right?
Exactly.
Okay.
It completely depends upon the demand. If they have demand of that server, that easy to instance, if their customers are using, then they will increase the price. And if those servers are vacant, that instance type is vacant inside the data center, then the prices are very low. It completely depends upon the demand. Okay. Okay, now let us talk about the dedicated host. Do you know what are dedicated hosts?
So isn't that when you're the only client on a server, like your server is like you've dedicated hardware?
Yeah, exactly, dedicated hardware. So in AWS, basically we have the concept of dedicated host, where we can basically purchase a server inside the data center. Okay, which server? Physical server. Right now, when we launch an instance, so that instance is basically running on a physical server. Okay, and it basically has instances running of some other customers also who are using AWS, right? Okay, let's say in AWS data center, there is a physical server. On top of that physical server, as we discussed in our last session, we have an hypervisor. And on top of that, we have our EC2 instances running. Okay, right now, let's say we launched one EC2 instance. We have one EC2 instance running. So this instance would be running on, let's say, in this server. On a physical server, it is running here. Let's say this is our instance. Now, there could be instances of other customers also. Other customers who are using AWS. Okay, other customers who are AWS using AWS. So these physical servers are shared across multiple customers, or we can say multiple AWS account holders. Okay, these physical server is shared across those customers. Okay, and when we now let's say we want to launch one more instance. Okay, so in that case, we cannot be 100% sure that this instance, the new instance which we want to launch, will be created on the same server. Okay, we will not be sure that the instance will be created on the same server. It could be created, or it could not be created. It would be created in some other physical server. Now let's say if it is created on some other physical server. So data center is basically a very big place, okay, where thousands of servers are there. Now let's say one server we have running on this physical host. Okay, one we are running on this host, and this is another instance we are running on some other host. Now, in this case, there would be a problem. The problem will be of latency. Let's say if this instance wants to connect to this instance, or this one instance, let's say this is basically a front-end application and this is running a database. So front-end application basically connects to the database. So for any business critical application, it will basically, there will be a latency. Okay, there will be a latency. Now to overcome this latency, if we would have the same server running here on the same physical host, okay, on the same physical host, if we had the same server, so there would be very less latency. Okay, there would be very less latency. Okay, and then another thing is in terms of security. Okay, as here we can see, like multiple customers are running the servers on the physical hypervisor, I mean physical host, right? So if we talk in terms of security, that is not much secure. Okay, anyways, that security is managed by AWS. But if we talk in terms of some compliances, so it's not secure. Okay, in terms of compliances. So in that case, basically what we do, we purchase a dedicated host. Okay, usually basically we purchase, let's say if a company wants to run a business application or finance application. So in those cases, basically we purchase a dedicated host. Okay, dedicated host is just a physical server inside the data center. It will be just a physical server inside the data center, and that physical server will have hypervisor also installed in it. Okay, this is, let's say, the hardware. This is the hardware, and this, on that hardware they will also install the hypervisor. And at the time of launching the instance, we can choose this dedicated host. So when the instance will be launched, the instance will be running on this dedicated host. So in AWS, we have to, in the console, we have to request AWS to allocate a dedicated host. First, you have to give a name. Now, which type of instance family you want to run on your dedicated host? Okay, as these instance type basically differs in terms of the hardware. Okay, they will be having different types of Intel processor, AMD processors, right? Now here basically it is asking which type of instance you want to launch on the dedicated host. Let's say we want to launch M5 instances. Okay, so we have chosen M5 here. Then we can enable support multiple instance types. So with this, we'll be able to launch any of the instance types of type M5. Then in which availability zone we want to purchase the or allocate the dedicated host. So we have to choose the availability zone. Okay, because this dedicated host is physically present in a availability zone. Let's say we want to purchase in this availability zone. Then we have instant auto placement. If we enable this option, if we enable this option, so at the time of launching the instance, automatically AWS will launch the instance in this dedicated host. Then if it is disabled, then we have to manually choose the dedicated host at the time of launching the instance. Okay, let's say when we launch the instance, so when we launch the instance and configure instance, basically we'll be able to see tenancy, shared, run a shared hardware instance. It will be running across multiple, on like where multiple instances are running by default. Then we have dedicated, runs on a dedicated instance. Then we have launch this instance on a dedicated host. If we choose this, then basically we have to choose the dedicated host. So first we have to purchase the dedicated host. Then we can also enable host recovery. Host recovery is basically, let's say, the physical hardware which is running inside that availability zone, if it fails. So if we enable this, so what AWS will do, it will migrate our instances to, I would say it will migrate our EC2 instance, it will reboot our instance and it will migrate it to some other dedicated host. Okay, some other dedicated host of same configuration. Okay. Then how many dedicated hosts we need? They also are giving the CLI command through which we can create the dedicated host. And then we just need to click on allocate. But we'll not be able to create a dedicated host. By default, AWS restricts us to create a dedicated host. So for that, basically we need to request, basically in service quotas, as we discussed in our last session about service quotas, where there are limits, like how many resources we can create in a service, right? So in EC2, for creating a dedicated host, let's say M5 dedicated host. So default value, here you can see default quota value is set to 0. And hence we are not able to launch an dedicated host. Okay, but some of them it is showing 1. I have actually requested before, that's why it is showing 1. But by default it shows 0. Okay, which is we are not allowed to create a dedicated host by default when we create a AWS account. So we have to request AWS, we have to basically tell them a use case, our use case why we need a dedicated host, and after that basically they allow us to create a dedicated host. Okay, and dedicated host basically we use for business critical applications where performance and performance of server and performance of network is high priority. In that case, basically we use dedicated host. And if we talk about pricing, so we just need to pay, let's say we are launching an instance of, let's say, M5. So we are only charged for that instance type. I mean, we'll be charged the hourly rate of that instance if we are purchasing the on-demand instance. And we are also charged an hourly rate of the dedicated host. Let's say if we have purchased the dedicated host, so we are also charged an hourly rate of the dedicated host. depending on the host we are purchasing. Depending on that, basically we have also to pay an hourly charge. Okay, so for dedicated host, there is an additional charge of additional hourly charge for each dedicated host. Okay, do you have any question till here?
I don't think so. Go ahead.
Okay. Okay, now let us talk about placement groups. Are you aware about placement groups?
Let's see. No, I'm not very familiar with this.
Okay, okay. Okay, so placement groups are basically, I would say, grouping, logically grouping a cluster. It's basically used for logically grouping, let's say, a cluster of EC2 instances. Okay, so with the placement group, we can cluster, we can create cluster of EC2 instances, and with that, basically, we can utilize more compute power. So when we create a placement group, so there are basically some strategies. Like based on that, basically we create a placement group, and also it depends upon use case. Now, let's say if we want to create for, I would say for low latency and high bandwidth. Okay, low latency, if you want to run a low latency application and where we require high bandwidth. So in that case, basically we create placement, we created with placement strategy as cluster.
Cut off.
Yes.
What does high bandwidth refer to?
High bandwidth, it means, let's say when we are accessing the internet, let's say we are downloading a file. So when we download a file, so basically depending on the size, there when we download the file, so basically it shows a download speed, let's say 5 Mbps or 10 Mbps. That is basically the bandwidth of the network. Okay. Now let's say if you want to download a very big file, and if it is every second it is taking 5-10 seconds to download it. Okay, so if it is a very big file, so it may take hours to download it. Now let's say if your download bandwidth is high, so in that case, basically you'll be able to download or upload a file very fast in minutes. Okay.
Okay.
Does that make sense?
What's the speed at which you can download or upload?
Yeah, it is basically the speed through which we can download and upload any kind of data. Okay, the group concept of placement group is similar as dedicated host, but it is more advanced as compared to dedicated host. In dedicated host, you are basically purchasing a server. Okay, you are basically purchasing a server, or not purchasing, I would say allocating a server. Okay, where we have to pay an hourly charge, right? Now the same concept we have in placement group, but here we are not purchasing any host. here the placement of the instances is basically managed by AWS. Now, depending on the strategy which we use, let's say we have cluster, we have partition, and we have spread. These are the three placement strategies. So let's say if we go with cluster strategies. So what it does, it basically launches the instance in the same availability zone. And it basically makes sure the instances are launched near to each other. Okay, the instances are launched near to each other. Let's say in data center, we have thousands of servers. So when we are creating a placement group, let's say of cluster, so AWS will try to create the instance near to that. I mean, it will be allocating, let's say, 4 servers, 4 physical servers will be allocating, and it will make sure the instances are placed on those servers only. Okay, and yeah, here you can see this strategy enables workload to achieve low latency network performance. Okay, do you know what is latency?
Yes, it's just the time it takes to
Response
complete
time,
something.
you can say. Yeah. Yeah, low latency network performance for necessary for tightly coupled node-to-node communication that is typically for high performance computing application, HPC application. Okay, so if you want to run, let's say, mostly this kind of use we have in banking application, where we perform any kind of transaction when the users are performing any kind of transaction, or when we are using, let's say, a blockchain technology. So in that case also we require low latency. Okay, so in that case basically we use placement group of type cluster strategy, where the servers are created. Like if you talk about a banking application or any application, so in application basically we have front end, we have API, and the backend. Backend is basically the database. So we need 3 servers. So if you are going to deploy it with cluster placement groups, so it will be deployed across. It will be deployed across multiple hosts, but those hosts will be, in terms of latency, they will be near to each other. Okay, whereas when we launch a EC2 instance, we are not sure where it is basically being launched. Okay, inside the data center, it could be like the first instance could be placed in the first server of the data center, whereas the other can be placed on the 1000 server of or let's say 500 host of that inside that data center. Okay, where basically we'll be facing latency issue. Okay, which will be latency will be very less. Okay, but if we talk in terms of banking application or blockchain application, where even 1 millisecond of latency matters a lot. So there basically we use dedicated host or this placement groups. Okay, where latency matters a lot. Okay, even if we try to ping google.com, okay, to check a latency of any server, we can just try to ping it. Let's say if we try to ping google.com. So here we can see the latency. Okay, from my end, the latency is 22 milliseconds, almost 22 milliseconds. Okay, which is very low. Okay, but for business application, we require, let's say, very less latency, let's say 1 or 2 milliseconds. So in that case, basically we use we use dedicated hosts, or we use placement groups. Now let's say if the same ping, if I run to localhost is my own computer. So here you can see the latency. It is 0.046. Whereas if I try to ping google.com, which is located in a different geographic location, so this is the latency. Whereas if I ping my own computer, or let's say if I try to ping my laptop, which is just near to my desktop, so there also we'll be able to see very less latency. Okay, so for some application where latency matters a lot, where in latency basically data is basically being transferred from or as a response is basically being transferred, it depends upon application to application, where a data is basically transferred or where a response is basically transferred to another host. There basically if latency basically matters a lot in such applications. So in that case, basically we use dedicated host or placement groups with cluster type strategy. Okay, does that make sense?
Yes.
Then we have partition based. So partition based, basically we can actually, there would be some diagrams as well. Yeah, if you see here cluster placement group, so in an availability zone, it will basically try to launch the instances on the same hypervisor or same physical host. Whereas if we see for partition placement group, it will basically launch the instances in multiple hosts, and these hosts will be near to each other. Okay, and all these placement groups are specific to a single availability zone. You cannot create a placement groups across multiple availability zone. Same as dedicated host. You cannot create dedicated hosts across multiple availability zone. It will be created only inside a specific availability zone. So here in this partition based placement group, basically we create partitions, and these partitions could be, let's say, a group of instances. Let's say when we are running an application in production, we do not run the application in just one server. Okay, the application will be running behind a load balancer where we'll be having multiple EC2 instances, which will be handling the traffic, which we basically do for high availability, right? So in that case, basically we create partitions, and that these partitions basically we have group of instances. Let's say front end, API server, database. So all servers will be running inside the same partition. The servers which are identical will be running on the same partition. That basically we decide. So the last one we have is spread placement group. Okay, where the server is basically deployed across racks. Okay, like in data center we have server rack. Okay, so in this spread placement group, it will be deployed across multiple racks. Okay, let's say we want to launch 5 instances, so it will be launched across 5 I would say 5 racks. Okay, and this is basically used for overcoming let's say if a rack has some network issue or it has some power issue. To overcome that, basically we use spread placement group. And let's say if the rack has some network issue or power issue, the servers will get down, and if the server will get down, the instance will get down. And if the instance will get down, our application will also get down, which will lead to a downtime, right? So to overcome that, basically we use spread placement group. But in spread placement group, we need multiple EC2 instances. Okay, so overall, if we talk in terms of in use cases, so here basically in spread placement group, we are more talking about in terms of at the hardware level. Okay, where we are talking more about network outage or power outage. Whereas in cluster partition placement group, we are talking more in terms of performance. And if we talk in terms of cluster placement group, here we are talking more in terms of network performance, where we are talking about latency and response time. Do you have any question?
Sure. So for the partition, okay, so this is where I'm sorry, no, spread is when you're worried about some sort of like hardware failure. You're trying to prevent fallout from that. And this is where you have like all of your instances, but then you have them on one rack, but then you also make sure that you have it on a distinct rack to prevent any kind of fallout from one of those racks failing, correct?
Okay, placement group is all over. It's all about basically, it's basically more about talking about how we want the instances to be placed inside our data center. Okay, I mean inside a availability zone. So that basically is part. Basically, we are talking in placement group, placement of instance in and availability zone. It's more about high availability for our instance. It's more about performance, network performance, failure. Right?
Yep.
Okay, let's have a break of 5 minutes and then we'll continue.
Okay, sounds good.
Okay, so we have some topics in EC2 like load balancing and auto scaling that we'll come to later after we are done with VPC. Then we'll come back to load balancing because it actually deals with networking, and before that the prerequisite actually for this is having an understanding of VPC service of AWS. So when we'll start VPC, after that we'll start this load balancing and auto scaling. Okay, now we'll be starting with RDS service of AWS. Are you familiar with RDS?
So that's for the like service configured for the database,
Yeah, exactly.
relational database.
Relational database service. Yeah. Okay, RDS is basically a relational database service. Okay. Before talking about RDS, let us talk about databases. Do you have any idea about database? What is a database?
Yeah. So where you store data in tables.
Okay. Okay, so yeah, so it is basically used for storing data. Okay. Now we have two types of databases. One is SQL database and NoSQL database. Okay. We have SQL and NoSQL databases. Do you know any difference between SQL and NoSQL?
Yes. So SQL has relational data, and NoSQL
Sorry, I think your voice is breaking.
Oh, can you hear me okay?
Yeah, now it is better, but I think it was breaking earlier. Okay, anyways. Okay, so in SQL databases, SQL basically stands for Structured Query Language. structured query language. Okay. And SQL databases. In SQL databases, the data is stored in the form of tables. Okay, in the SQL database, the data is stored in the form of tables. Whereas NoSQL, the data is stored in key value form. Okay, key value format. Here basically NoSQL, the data structure is, we can say, JSON. Okay, the data is basically stored in JSON format. Whereas in SQL, it is stored inside tables where we have rows and columns. Okay. Another difference is retrieval, the data retrieval. Let's say we have stored some data inside the database. So if we talk about NoSQL, the data retrieval is fast as compared to SQL databases. Okay, as compared to SQL databases, the data retrieval is very fast. Now, if we talk about SQL databases, so the data retrieval is slow. So what is data retrieval? Like when we run some SQL queries like select asterisk from XYZ database, so it basically retrieves the data from the database and basically displays the data, right? So the data retrieval in SQL databases is slow as compared to NoSQL databases. Okay, and here basically we use, in SQL database we use, to query the data we use SQL queries. To query the data we use SQL queries. Whereas here in NoSQL database, we don't have SQL queries. That's why it is called NoSQL. NoSQL. Here we don't have any SQL queries. Here we use functions. Okay, functions built inside the database to retrieve the data. Okay, for actually everything which we do in NoSQL database is done through functions. Now let us talk about the types of SQL database. Do you know any SQL database?
So there's PostgreSQL, MySQL.
Okay.
What else? Those are the two that come
MariaDB.
to mind. Oh yeah, MariaDB.
Microsoft SQL Server, MS SQL Server. Microsoft also have their own server, which is called MS SQL Server, which is only which can only be used in Windows operating system. And also we have Oracle database. So these are some of the examples of SQL databases. Now, if we talk about NoSQL database, do you know any NoSQL database?
Yes. So MongoDB is one that comes to mind. Yeah, that's the only one I can think of.
MongoDB, we have MongoDB, we have Cassandra. MongoDB, we have Cassandra. Cassandra is also a NoSQL database. We have Redis, okay, which is also a NoSQL database. We have MongoDB, Cassandra. Cassandra is used by MongoDB is used by Facebook. MongoDB, Cassandra, Redis. In AWS, we have DynamoDB, which is also an implementation of NoSQL databases. Okay, So these are the commonly used NoSQL database: MongoDB, Cassandra, Redis. As the company is using the AWS, they usually prefer using DynamoDB. Okay, do you have any question till here?
Nope.
Okay, now let us talk about RDS. So in RDS, basically we create SQL databases. Okay, we create SQL databases. RDS doesn't support NoSQL databases. And in RDS, we can create 6 types of, it basically supports 6 types of database engines. Okay, which are MariaDB, let's say MySQL, MariaDB, PostgreSQL, Oracle Server, MS SQL Server, okay, so these are 5 databases: MySQL, MariaDB, Postgres, Oracle Server, MS SQL Server, and AWS has its own database which they have created, which is Amazon Aurora. Okay, Amazon Aurora database, and this database is created by AWS. This database you'll only find in AWS. Okay, outside of AWS will not find this database. Whereas these other database like MySQL, MariaDB, PostgreSQL Server, Oracle Server, MS SQL Server can be installed anywhere. Even in our local machine, we can install these databases. Whereas Amazon Aurora is only available in RDS. Okay, usually this question is asked in the certification exam, like what are the database engines supported in AWS? So these are the 6 database engines which are supported in AWS. Okay, and this Amazon Aurora database is also a SQL database which is compatible with 2 databases. Which is compatible with 2 databases, which are MySQL and Postgres. Which are MySQL and Postgres. Okay, Amazon Aurora is basically compatible with MySQL and Postgres. So if you have an application which support MySQL, so in that case you can go with Amazon Aurora database, which is cheap as compared to other database engines. Plus, it has a lot of other features which we don't have in these database engines. Okay, also RDS is an AWS managed service. Okay, what does AWS managed service means?
It means that AWS takes care of all the configuration and maintenance and updates.
Exactly. So the reason why RDS is popular or why companies use RDS is that we don't have to manage the server. Okay, let's say we want to deploy a MySQL database. So the same database we can deploy in a EC2 instance also. Okay, but the problem is if we deploy it in a EC2 instance, we have to manage the EC2 instance, plus we have to take care of the database as well. Like we have to take care of compliance, we have to take care of security, we have to take care of updates. Okay, and on the instance also we have to take care of operating system patches, upgrades, right? So there is a lot of things we have to take care of, right? If we are managing it by our own. Also, we need a database administrator for managing the database server, right? Whereas if we are using the RDS database, so here everything is managed by the cloud provider. Everything, I mean the server where it is running, plus the database also is managed by the cloud provider. And what we do, we just access the database. They basically will provide us an endpoint. With that endpoint, basically we can access the database, and with that basically we can store our data inside the database. Okay. Plus, I mean, AWS basically takes care of the underlying infrastructure. It basically performs security patches, maintenance, everything is taken care by AWS. Plus, RDS is compliance, HIPAA compliant. HIPAA and PCI compliant. Okay, do you know HIPAA and PCI?
HIPAA is health privacy, I believe, and
Yeah, and PCI is public public. It's actually related to data only. PCI. Yeah, public data security. It's for public council. PCI compliance. Yeah, sorry, payment card industry. It's basically for data security. Okay, where basically finance or banking application we have. So in that case, basically we use this PCI compliance. And RDS is compliant with the HIPAA compliance. Yeah, these, yeah. These include SOC. SOC is also very popular. PCI compliance, FedRAMP, HIPAA, and others. FedRAMP is basically created by the US government. Okay, so it is also compliant with these compliances. Whereas if you are going to launch a EC2 instance, and in that if we will be configuring the SQL database, so we have to go through a lot of list of this compliances, and then we have to configure or tune our database with these compliances. Okay, so that will be a little time consuming also, right? Whereas here AWS basically takes care of that. Okay, and it is an AWS managed service where everything is managed by the cloud provider. Now let us see how we can create a database. So here we'll go to RDS. If we click on services, under databases, we'll find RDS. Okay, then here we'll go to databases. And here we'll click on create database. So we have standard create and easy create. So we'll go with standard create, which will basically give a lot of flexibility to make changes in the configuration. Whereas if we go with easy create, so it will be created by best practices and configuration, which is recommended by AWS. Okay. So we'll go with standard create, which will give us a lot of configuration options. Then we have to choose the instance type, engine, database engine. As we discussed, there are 6 database engines: Amazon Aurora, MySQL, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server, right? So yeah, first we'll go with MySQL database. So you can see MySQL community. If we go with Amazon Aurora, so here you can find 2 compatibilities are available for Amazon Aurora: MySQL compatibility and PostgreSQL. If we'll be deploying MySQL compatibility, so that database will be working same as MySQL database. If we'll deploy Postgres, so that database, Amazon Aurora database, will be working same as PostgreSQL databases. So for now, we'll go with MySQL. Then which database version we want to deploy. Then what is our use case? So we'll go with production, which will give us a lot of configuration options. Then we have to give the database name. Let's say prod DB instance. Then credentials. Here we basically have to set the credentials which we are going to use to log into the database. So let's say username admin, then the password. Okay, so to log into the database, we'll require this username and this password. We can also choose auto-generated password, which will generate a random password. Okay, and this will be generated once we'll be able to see this password when the database is created. So depending on our use case, it's actually recommended that we go with auto-generated password because it will come with a strong password. Then DB instance class. Now the DB instance class is same as instance type in EC2. So depending on our use case, like we have standard class, memory optimized class, which will have less CPU and more memory. Now it completely depends upon our use case. Now what kind of application we want to run and what kind of data we want to store, and what will be the number of servers which are going to access that database. Depending on that, basically we have to choose the instance class. Okay, now in free tier we have dbt2.micro. So for that, first we have to enable this include previous generation classes, and in that basically we have t2.micro, and t2.micro basically comes under the free tier plan. Then storage. Storage here we have of three types: provisioned IOPS, general, and magnetic. I think we skipped one topic in EC2, which is volumes. Okay, after this RDS we'll talk about that, where basically only one part is left, which is like the type of volumes which we can create in EBS. Okay, so here basically we have RDS is offering three types of volumes, which is provisioned IOP, general purpose, and magnetic. Okay, do you know the difference between any of these storage types?
I think that the IOPS is faster, right? That's about all I really know.
Okay. Okay, yeah. So exactly, it depends. It differs in terms of performance. Okay. So let's say if we are using provisioned IOPS, it actually depends upon read write on our disk. Okay. In terms of disk, if we talk in terms of performance, so basically disk performance is basically measured in read write speed. Okay. It is measured in read write speed. So provisioned IOPS basically have high throughputs, or I would say high IOPS, with which basically the read write speed of provisioned IOPS is higher as compared to general purpose. Okay, both are type SSD. Okay, SSD is basically the hardware through which this volume type is created. And then we have magnetic. Magnetic is also a type of SSD, but it has low performance. Okay, it has low read write speed as compared to general purpose and provisioned IOPS. We'll talk about this in detail when we'll be talking dedicatedly about EBS volume types. Now, depending on our use case, depending on what application we want to run, we have to choose the instance type. So for now, we'll go with general purpose. Like when we launch our EC2 instance, also by default, we go with general purpose. Okay, and the minimum size should be 20 GB and maximum it can go up to 16 terabyte. And the same maximum limit we have for our EC2 instances also. Like we can create our for our EBS volume in EC2 also. Like we cannot create a EBS volume more than 16 terabyte. Okay, we cannot create a EBS volume of size more than 16 terabyte. So the same limit we have here also. Now there is one cool feature which we have in RDS, which we don't have in EC2, which is of storage auto scaling. So with storage auto scaling, let's say if 20 gigabyte of storage is full, then your database will not be able to store the data and you may lose some data, right? Let's say at 2 a.m. your database got full. Okay, 20 GB is completely utilized. And after that, basically any data which is basically going to be stored inside the database is not getting stored, right? So in that case, basically you are losing the data, right? And to overcome this, basically we have this feature which is of storage auto scale. With storage auto scaling, what it will do, if a certain threshold is crossed, let's say when 90% of disk is utilized, okay, 90% of storage is utilized, it will automatically scale up the storage. Okay, so here we can set a, here we can set a limit, let's say 50 GB. So it will automatically scale up to 50 gigabytes. Okay, when 20 GBs, or I would say 90% of 20 GB is utilized, let's say 18 GB is utilized, it will automatically scale up the storage. Then we have multi-AZ deployment. Okay, multi-AZ deployment is basically for high availability. Okay, it's for high availability and failover. So right now, when we launch an EC2 instance, okay, RDS multi-AZ deployment. So when we launch a EC2 instance, first let us compare it with EC2 instance. So let's say when we launch one EC2 instance, so it will be launched inside a region, inside a data center, right? Inside availability zone, basically. So let's say this is one region and it has 6 availability zone, like we have in Virginia. And when we launch a EC2 instance, let's say the EC2 instance is launched in this availability zone. Now, for some reason, if this instance gets down, not this instance, I mean this availability zone gets down due to, let's say, any natural calamity, if the availability zone gets down, and if the availability zone gets down, the instance running in that availability zone will also get down, right? If the data center gets down, the instance will get down and it will result in application downtime, right? So in case of EC2, there is no high availability. There is no high availability or there is no failover, right? Failover, it means, let's say if this instance is down, there is another server which will be handling the traffic. Okay. But in case of EC2, we don't have any failover or we don't have any high availability. So in RDS, basically, we have a concept of multi-AZ deployment. And with multi-AZ deployment, okay, with multi-AZ deployment, let's say we have a region. And we have 4 availability zones. Okay, let's say we have one region, we have 4 availability zones, and these RDS databases are also created in a availability zone. So let's say when we are creating a RDS database, let's say it is created in this availability zone. Okay, let's say this is the region Virginia, US East 1. So the first availability zone will be US East 1A. The second availability zone will be US East 1B. The third will be US East 1C. Fourth will be US East 1D. Okay. So let's say when we launch the RDS database, it will be launched then inside a availability zone, the same way a EC2 instance is launched, right? Now, let's say if the same case happens, let's say if this availability zone gets down, for some reason, if the availability zone gets down, the RDS database will be down. And if the RDS database is down, application will be down, right? Because if it is a, let's say, application which connects with the database, so if the database is not responding, the application will also not respond properly, right? Like the users will not be able to log into the application. Okay, and a lot of other features will not work inside the application if database is down. Now with RDS multi-easy deployment, if we enable multi-easy deployment, which is actually an optional feature, if we enable this multi-easy deployment, what AWS does is it basically creates a standby database. It creates a standby database in another availability zone. Okay, in the same region, it creates a standby database in another availability zone. Okay, for failover. So this database is basically our primary database, primary DB server, DB instance. And this will be our standby DB instance. Okay, this is our primary DB instance and this is our standby DB instance. And at a time, only one server will be active. Okay, let's say this primary database will be always active. And this standby database will be in inactive state. Okay, it will be in inactive state, which means, let's say we have one EC2 instance which is running a web application. Okay, so this EC2 instance, the web application will be connecting only to the primary database instance. It will not connect to the standby instance. Now, let's say if the availability zone fails or there is any hardware failure or anything goes down, which will affect the instance, which will affect the primary database instance. So in that case, it will automatically fail over to standby instance. It will automatically fail over to the standby instance. And this standby instance then will become active. Standby instance will become inactive and this will become inactive. So then the web application will start connecting to the standby database, which is in some other availability zone. Okay. Also, there is one more thing. Let's say initially when it is connecting to this database, which is in active state and storing all the data in this database, right? And this database is in inactive state and it is not accepting any connection. So RDS basically what it does, it basically synchronizes the databases. Any data which is created here will be created here as well. Within milliseconds, the data is replicated across the standby database instance. So any data which is created in this database, it will be replicated here as well. So both the databases are in sync. Okay, both the databases are in sync. And they basically use synchronous replication. The replication mechanism which is used is synchronous replication. Okay, synchronous replication is used to replicate the data across the primary and standby database. Okay. Do you have any question?
Yes. So if the primary database instance fails for a reason other than availability zone failure, will it also transfer to the standby, or is it only if the availability zone fails?
Yeah, actually it's for availability zone also and it's for hardware failure also. Let's say the RDS database which is running on a physical hardware, if that fails, so it will shift the traffic to the standby instance.
Okay.
Yeah, so with this, basically, we overcome a problem, a challenge, which is failover. It will, I mean, it's basically of high availability. Okay, high availability basically means 100% uptime. Okay, high availability basically means 100% uptime. So to achieve 100% uptime, we require multiple servers, okay, which will be hosting the application. Okay, in this case, we have multiple databases. So it basically solves the problem of high availability. So even if this database get down, we have another database which is accepting the connection. So with this, basically, we are achieving high availability. Okay, and this is also a failover deployment. Failover, it means, let's say if this database gets down, it will automatically start sending the traffic to this database. So it's also called failover deployment. Okay, in the certification exam, they will be asking, they will not be directly asking what is multi-AZ deployment, or they will be just giving you a use case. Let's say a company wants a scenario-based question, like a company wants to deploy the database and they want to ensure high availability, and they also want to set up a failover database. So in which of the RDS deployments can be used? Okay, in RDS, basically, we have two types of deployment. One is multi-AZ deployment and one is read replica. Okay, so they will give multi-AZ deployment, read replica, none of these, or all of the above. Okay, so the answer would be multi-AZ deployment, with which basically we are achieving failover and high availability. Okay, in the certification exam, mostly for all the core services, there are 5-6 core services, which is the part of the certification exam. And for all the core services, there will be questions based on use cases only, not use cases, scenario only. Okay, they will be giving you a scenario like there is a company, they want to do this. So which service of AWS they should use? Okay, so the questions will be scenario based. Okay, and there would be direct questions also, like which replication RDS multi-AZ deployment use? So AWS RDS multi-AZ deployment use synchronous replication. Okay, synchronous replication is in use. They may ask at a time, let's say in multi-AZ deployment, which of the database is active? So they may give option like primary DB is active, standby DB is active, both are active, none of these. So in multi-AZ deployment, only primary databases is active, okay, which is accepting the connection, whereas standby is in inactive mode. No traffic is sent to the standby database instance. Okay, so whenever we are going to do a deployment in production environment, so we always use multi-AZ deployment. There is one more advantage of using multi-AZ deployment, which is of snapshots. Okay, in RDS also we create snapshot, like in EC2 we create snapshot. The same way we create snapshot in RDS also. So when we create a snapshot, what it does, it basically creates a clone of that instance, right? Basically creates a clone of that instance. And when it is basically creating a clone, so there is it basically affects the performance of the instance of that point of time, right? Let's say if the backup is going to take 30 minutes, so the performance of the database is affected when we are doing the snapshot. Okay, because at that time, when the snapshot is going to create, there will be a lot read write operation, right? There would be a lot of read write operation, not write operation, only read operation. It is just going to copy the database, read the database, and copy the database to a snapshot, right? Which is just a clone of that disk, right? So if there is a lot of read write on the disk, so it will affect the performance. Okay, so in that case, if we are using multi-AZ deployment, so the snapshot is basically created of standby database. whenever we request a snapshot, so the snapshot is created of the standby database. And if we are creating the snapshot of standby database, the primary database is untouched. Okay, the primary database is untouched. So there is no read write operation, any kind of operation performed on the primary database in case of snapshot. Whereas, and the snapshot is basically created of the standby database instance. So performance is not affected at the time of creating snapshot. If we are using, yeah.
So how often does the primary sync with the standby?
Primary sync with standby? No, standby is syncing with primary.
Oh, that's okay. So how often does that happen? Like how?
Once the data any data is written here, instantly.
Okay, instantly. Okay.
Yeah, within milliseconds, it transfers the data, replicate the data to the standby DB instance.
Okay, at all times. So not even in the instance of the failover, just at all times, it's up to date with the primary.
Exactly.
Okay,
It's sync in both the database. Yeah, and here you can see creates a standby and different availability zone to provide data redundancy, eliminates input output fees, and minimize latency spikes during system backups. So basically, backups are created of the standby instance. So this is just a feature. If you want, you can enable. If we don't want, we can disable it. But it is recommended that when we are doing a deployment in the production environment, we use multi-agent deployment. There is high availability of the database. Then we have VPC. VPC we'll talk later when we'll be talking about the VPC service. Subnet also we'll talk later. Now access type. Now RDS offer two types of access. One is public access and one is private access. If we enable yes, so we are enabling the public access. Public access means that database will be accessible over the internet. Okay, if we go with public access, the database will be accessible over the internet. If we go with private access, then it will only be accessible to our EC2 instances running in our AWS account. Okay, so it will be only accessible to our EC2 instances running in our AWS account. So if we are creating it in private mode, then it is more secure. Okay, if we are creating it in public mode, then anyone can try to connect to the database. Anyone on the internet can try to connect to the database. They can perform any kind of DOS attack or any kind of attack to gain access to the database if it is publicly accessible. If it is privately accessible, then it will be only accessible inside the EC2 environment. EC2 environment means in this account it will be only accessible to the EC2 instances which are running in Virginia. Okay, if we create it as a private database, which is by setting it to no. Now it completely depends upon the use case. Okay, now let's say you have your web application running in AWS. So in that case, you can create it with private endpoint. But let's say if you have your application running outside of AWS. Okay, outside of AWS means which is running on premises. Okay, let's say the company has their server on the on-premises itself. So in that case, we need to create the RDS database with public endpoint. Okay. Okay, if the database, if the I would say the application is outside of AWS, in that case we go with public endpoint, and if it is inside AWS, then we go with private endpoint. Okay, keeping it in private access is more secure. Okay, whereas creating it with public endpoint. And database is a very sensitive thing because it basically has the data of users. Let's say sign up details, passwords. Okay, if it is a banking application, it may have credit card details, right? So it's a very sensitive, I would say, sensitive resource. So it is recommended that we create it in private access, and it actually completely depends upon the use case. Okay, if we have resources outside of AWS or the servers which are outside of AWS, in that case we have to create with public endpoint. And if it is in AWS, then we create it with private endpoint. Okay, then we have to attach a security group. Now we can create a new security group here, and in the security group we have to ensure that this port is open. MySQL by default works on port 3306. This is the default port of MySQL. For Postgres, it is 5432. Okay, they may ask, it can be asked in the certification exam, the default port of MySQL, the default port of Postgres. Okay, these are the default ports. We can also change the port number. Okay, through this we can change the port number. Let's say we want to run it on port 5000. So here we can change the port number. And at the time of creating this security group, we have to make sure that this port is open inside the security group. If we are creating the security group, then automatically it will has, based on the port number specified here, it will automatically have a rule here. If we are going with choose a security group, choose an existing security group. So here it will show all your security groups in your account. So we'll go with create a new security group. Let's say my RDS security group. My RDS security group. Okay, we'll go with the default port. Then authentication type. So basically we have three types of authentication. One is password authentication, which is the default type, default authentication in MySQL, through where we just need to provide username, password, and we are connected to the database. Another way is password and IAM database authentication, which is if the user who is connecting to the database, if the user has access to, if the user is an IAM user, then only he will be granted access. In case of password and IAM database authentication, it will validate the username, password, plus it will also validate whether the user who is trying to log into the database exists in the AWS account or not. Okay, so this is more secure as compared to just having password authentication. Password authentication, anyone on the internet can try to connect to the database. But with this IAM database authentication, only authorized user can try to connect to the database. Then we have password and Kerberos authentication. Kerberos is basically an authentication server, which is basically developed by MIT. It provides token-based authentication. So to connect to the database, first it will generate a token, and with that token, basically we'll be able to connect to the database. For now, we'll go with password authentication. Then additional configuration. So if you want to create a database, let's say currently what we are doing, we are spinning up a database engine. Okay, and in that database engine, we create databases. So let's say if you want to create a default database, if you want to initialize your database engine with a database, so here we can give the database name. Let's say MyDB, let's say AppDB. Okay. And parameter option group, we'll talk about this later. This is more about configuration of the database. From this parameter group, basically we can do any configuration changes for the database, because here in RDS we don't have the server access, and as we don't have the server access, so we cannot do any kind of configuration changes. So those configuration changes are done by parameter group, and option groups are basically used for integrating it with some other services. Let's say you want to enable caching, okay, caching using Redis or Memcache. So that integration basically we do with option group. Then backups. Backup is nothing but snapshot. Okay, here just we are calling it as backup, but in actual it is creating a snapshot. So here RDS provides us automatic backups, whereas in EC2 we don't have any automated backups. Okay, there also we have where we have to create life cycle rule, right? We have to create the life cycle rule, but here we have automated backups. Okay, so here basically we can set a retention, like how many days we have to create the backup up to. So the maximum days is retention max is 35 days. Okay, this can be asked in the certification exam. The max duration of retention in RDS. So it is max duration of retention of RDS automated snapshot. So it is 35 days. Okay, so it will keep the snapshot of last 35 days. An older one, it will keep on deleting it. Then backup window. Okay, backup window is also important. If you are running the database without multi-easy deployment, then the backup windows really matters. If you're not creating with multi-easy deployment, then you can set it to no preference. Okay, if you are creating with without multi-easy deployment, then you should set a backup window. Okay, which will be a time. At that time, basically, it will be creating the backup. Okay, let's say we want to create the backup daily at 1 a.m. UTC, and the duration is 30 minutes. So at this time period only it will create the backup. Then monitoring. By default, there is no enhanced monitoring. Like the same concept actually we talked in EC2. Like in EC2, we had two types of monitoring: detailed monitoring and enhanced monitoring. Oh, sorry, basic monitoring and enhanced monitoring, right? No. Which was basic monitoring and detailed monitoring. Okay, here the name is different. In EC2, we had basic and detailed monitoring, right? Let's say we have, yeah, manage detailed monitoring. So by default in EC2, there is basic monitoring. So the same basic monitoring we have for our RDS database also. Now, here we have one concept of enhanced monitoring, which is same as detailed monitoring here, right? Here with detailed monitoring, currently there is a delay of the data. There is a delay of 5 minutes. Okay, we see the data after every 5 minutes. And when we enable detailed monitoring, we see the data after every 1 minute. After every 1 minute, the data is updated here. So the same way here, if we enable enhanced monitoring, we'll be able to see the data after every 60 seconds. We can also actually set the granularity. We can also set it for 1 second. So instantly, when there is utilization inside the database, we'll be able to see the data in real time. If we set it to 1 second, almost real time, if we set it to 1 second. Okay, and by default, it shows after every 5 minutes. Okay, if it is a production database, then it's recommended that we use enhanced monitoring. Then we have the database log, error logs, general logs, slow logs, which are generated in RDS console itself. If we want to publish to AWS CloudWatch, which is basically monitoring and logging service of AWS, so that also we can do. Okay, this we'll talk later, and we'll be talking about CloudWatch. Then upgrades, database upgrades, and any kind of maintenance, okay, which AWS basically does on our behalf. Okay, so it is recommended that we enable any kind of minor version upgrades, okay, which is minor database upgrades. Okay, database version upgrades. So here we can set a maintenance window, and on that point of time only it is going to make the changes. So let's say on Sunday at 2 a.m. UTC, for 30 minutes. So at that period of time, it will perform the maintenance. Also, we can enable deletion protection, okay, which is same as termination protection in EC2. Did we talk about termination protection in EC2?
I think we did. It's just an extra step you have to take if you're going to delete it. Or actually, isn't it the root volume can never be deleted or something like that?
No. I think we didn't discuss about termination protection. It's just like it's basically locking the instance. Okay, like let's say we have this instance running, and if we just click here terminate, and it will just terminate the instance. Okay, but let's say if you have some production server, let's say you have one production servers and 5 testing servers, and let's say you want to delete those 5 testing servers, and by mistake you also deleted the production server. Okay, by mistake you also chose the production server. So in that case, your production server will be deleted. But with termination protection, we can add a lock on the server. Okay, like in instance setting, yeah, here we have termination protection. So we just need to enable this termination protection. Once we enable this termination protection, there will be a lock on the instance. Okay, which means we'll not be able to terminate the instance. Manually, we'll not be able to terminate the instance. Even if we choose the right instance and if we click on terminate, we'll not be able to terminate it. Okay, so we have to disable that lock, and then we only will be able to terminate it. Okay, it's basically used for it is basically used to overcome accidental termination. Okay, like if we accidentally terminate the instance, to prevent that, we enable termination protection on production instances. So the same concept basically we have in RDS, which is of deletion protection. If we enable this, so we'll not be able to delete the database unless we disable this setting. Okay, now if we talk about pricing, so this is the monthly price of the RDS database, and this is the storage price of the disk, which is of 20 gigabytes. And as we are deploying the multi-easy database, as we are deploying the multi-easy deployment, so if you see the price is same. Okay, if you are going with multi-easy deployment, you have to pay twice of the actual database if you are going with multi-easy deployment, because in multi-easy deployment, AWS will keep on running one additional server, right? So with multi-easy deployment, our cost goes double. Here we'll click on create database. Okay, it will take at least 5 minutes to provision the database. Do you have any doubts, any questions still here?
Nope.
Seeing up.
Okay. Let's have a lunch break of 30 minutes, and then we'll continue from there.
30 minutes.
Yeah, 30 minutes.
Okay. Sounds good. Thanks.
Okay. Hi, Tyler, can you hear me?
Yes. Can you hear me?
Yes. All right. Okay, so we have the database instance running, and it is in available state. Okay, now as we have, if you click on this database, So it has basically generated a endpoint. Okay, and this is the endpoint through which we basically connect to the database. Okay, so to connect to this database, what we'll do is we'll launch one EC2 instance. As it is created in private endpoint. Okay, private endpoint here you can see publicly accessibility is set to no, which means it is a private endpoint, private database, and it is only accessible in AWS environment, which means it will be only accessible to EC2 instances running in this region in Virginia. So here we will launch an instance. Okay, so our EC2 instance is in running state. We'll just give it a name. Let's say web server. And from this instance, we'll try to connect to the database. Okay, before doing that, we'll just go to our RDS console. And here we click on this database. And here we can see the security group which is attached to this database. So we'll just open this database, the security group of this database. We'll go to inbound rules. And here we can see inbound rules, but it is only allowed to my IP. Okay, so here we will allow it to the instance IP. Okay, here we will only provide access to, let's say we want this instance to connect to the database, So what we'll do is we'll just copy the IP address of this instance inside the security group. Okay, allowing access on port 3306. And then we'll click on save rules. Okay, then we'll connect to the EC2 instance, the public IP. Okay, we are logged into the EC2 instance. And after logging to the EC2 instance, we will install the MySQL client. So for that, we can just install MariaDB. MariaDB, we can also use the MariaDB client, which will be like a client software through which we will be connecting to the RDS database server. So we will run this command sudo yum install MariaDB. And then we'll use this command mysql-h, and in this -h we'll provide the database endpoint. This is the endpoint of the database of the RDS instance. Then -u, username is admin, which is the default username. Then -p. -p is basically used for prompting for the password. So the database credentials have been generated. So here we'll click on view credential details. And this is the password of our database. And we are connected to the database server. Now here when we run show databases, so we should be able to see the databases created inside the RDS database server. So here we can see AppDB. If you remember at the time we were creating the database instance, so we chose that option which was initialized with a default database. So this is the name of that database, AppDB. Okay, so we are successfully connected to the RDS database. Show databases. Then let's say we want to use AppDB. Like we want to connect to that AppDB database. Then show tables. Okay, so we are connected to the database. So the same way our application will connect. Okay, we just need to configure the application with this database endpoint, the username and the password. Do you have any questions still here?
Yes. So when you installed MariaDB, was that
Like to SSH to the EC2 instance, we use let's say terminal, right? And in Windows we use Remina to connect to the RDP, right? So the same way to connect to the MySQL server, we need a SQL client. So MariaDB is also a SQL client, which is similar to MySQL client. So that's why we use the MariaDB.
okay?
The map says
Yeah. Okay, so as it is in the private endpoint, so our EC2 instance only can connect to it. Okay, and also in the security group, we also restricted that only this EC2 instance can connect to it. Okay? So only this EC2 instance can connect to the database, your RDS database instance. Okay. Also, at the time of creation of the database, we enabled multi-EZ deployment, right? So if we go to configuration, so here we can basically get that information. Let's say availability and multi-EZ is set to yes, and the secondary database, the standby database is created in this availability zone. We cannot see this as standby database. It is at AWS end. So it is created in this availability zone. And our main instance is created in this availability zone, primary instance, US East 1F. And the standby instance is created in US East 1A. Okay, and here we can see the information like the database name, which version it is using, what database we created, which license it is using, which option group it is using, what is the resource ID of the database, when it was created, which parameter group it is using, deletion protection is enabled, the DB instance size, what is the RAM, CPU, what is the RAM, what is the default username, whether IMDb authentication is enabled or not, multi-AZ is enabled, and the instance is created, the standby is created in this availability zone. We didn't had any encryption on the storage. And it's using general purpose SSD. Storage is set to 20 gigabytes. Storage auto scaling is enabled. And maximum storage threshold we have set it to 50 gigabytes. Okay, and if we go to automated backups, so it would have created one backup as well. Okay, this is the database name. If you scroll down, yeah, so at the time when the database was created, it also creates the snapshot of the database. Okay, and here we can get the database endpoint and which port it is listing on, which availability zone it is deployed in, which VPC. This is more information related to network, and which security group it is using, which whether it is publicly accessible or privately accessible. Right now it is privately accessible. Which certificate it is using for encryption. Okay, and it has a replication enabled. Replication enabled on the database instance.
Hi, Gaurav. Sorry about that. I had a issue with my internet connection.
Okay. Okay, then in monitoring, we can see the resource utilization, let's say CPU utilization, database connections, storage usage, and free memory, write-ops, read-ops, read-write utilization, disk utilization. Lots of information actually we can get. We can see through ports. Then in logs and events, we can see all the events of the database when it was created, when the backup was initialized. And here the log files are generated. We can also see the log files. Okay, we can see it on real time also. We can refresh it. Okay. A lot of information basically we can get of our database. Maintenance and backup tab, we can see when the maintenance is scheduled. And if there is any pending task, so that task will be displayed here. The retention backup we have enabled. How many snapshot it has created. So it creates automated snapshot, and we can also create a manual snapshots. Okay, manual snapshot we can create of any time. We can just click on take snapshot, give the instance name and the snapshot name, and the snapshot will be created. So we can also create manual snapshot. Okay, and by default at the time of creating the database, we can enable automated snapshot where the retention maximum retention period is of 35 days. Okay, now let's talk about query editor. So query editor is a feature which is only enabled for Amazon Aurora. Okay, it is a feature of RDS which is only supported in Amazon Aurora. Okay, by this basically we can run SQL queries here itself. Okay, we can run our queries, SQL queries, and we can see the output here itself. We don't have to launch an EC2 instance to connect to the database. Okay. Here itself we can see we can run the SQL queries, let's say show databases, use database, and we'll be able to see the output here. But this is only supported in Amazon Aurora. Okay, query editor is only supported in Amazon Aurora. And also for that, in Amazon Aurora, at the time of creating Amazon Aurora, we need to enable the API. Here you can see it is only supported in Amazon Aurora serverless database. Only Aurora serverless database that you have access to will be displayed here. Okay, so it is only supported in Amazon Aurora databases. We have performance insights. So with performance insight, this is also a feature, and this feature we have to enable on the database. Okay, but by default it is not enabled. At the time of creating the database, to enable it, or even after creating the database also we can enable it. Okay, so with this basically we can see like what processes are running inside the database server, and we can see the traffic on the database server. Okay, it's more at the resource level. At the resource level we can see, not at the resource level, at the software level we can see lot of information of our database. Okay, we already talked about snapshots. This snapshot are manual snapshot, an automated snapshot which is created, which is enabled on the database, which is created by AWS, then reserved instances. So here we have the same concept of reserved instances. Right now, the database which we deployed is of type on demand. Okay, on demand it means there is an hourly rate of that database. Whereas we can also deploy a database as a reserved instance, and we can get the same advantages which we have in reserved instance which we had in EC2, like where we can purchase the instance for 1 or 3 years, okay, which is very cheap as compared to the hourly rates. So the same concept basically applies here as well. Okay, we can create we can purchase a reserved instance for a year or 3, and we can create a reserved instance for 3 year, 1 year or 3 year, and it will be cheap as compared to the on-demand price. Okay, but the problem with the reserved instance is that we cannot change the instance type. So the same applies here also. We cannot change the instance type of the reserved instance. Okay, proxies are not a part of the exam. Subnet groups, we'll talk about this later. It's just about the network which is basically used to deploy the database. Now let's talk about parameter groups. Do you have any questions still here?
Nope.
Okay. All right. So now let us talk about parameter groups. So as we know, these this RDS database is managed by AWS. So all the configuration, let's say all the configuration is also managed by, I mean the server level configuration is also managed by AWS. Okay, and we don't have access to the server. As we don't have access to the server, we cannot do any configuration changes. Okay, we cannot do any kind of configuration changes like database tuning. Like we cannot change any connection pools. A lot of other settings are there inside the database, right? So in that case, what we use parameter groups, and with parameter group we can do any all kind of database configuration we can do using parameter groups. Okay, so when we create the database, our default parameter group is attached to the database. Okay, there are two types of parameter group. One is default parameter group and one is custom parameter group. Default parameter group is created by AWS, whereas custom parameter group we create. Okay. Another difference which we have in default parameter group and custom parameter group is in default we cannot modify the default parameter group. Okay. Let's say we have to make any configuration changes on our database. So let's say we chose this one, default.mysql 8.0. Now let's say if you want to make any changes, let's say we want to increase the connection pool. Okay, or we can say max connection. Okay, max connection. Yeah, so let's say if we want to change this information or any of this information. So basically what we will be doing, let's say edit parameter. So let's say we want to change the parameter. Let's say we want to change this character set connection. Let's say we want to change it to big 5. And now we want to save it. So it says that you cannot make any changes in the default parameter group. So the default parameter group is created by AWS and we cannot make any changes on the default parameter group. Now let's say if you want to make changes in the parameter group, so what we have to do? We have to create a new parameter group. And the new parameter group we have to then attach to our RDS database. And then we'll be able to make any configuration changes. Okay, we cannot make any changes in the parameter group. Do you have any question till here about parameter groups?
I mean, I guess this is a little fuzzy for me, but I think I get the general concept.
Yeah, it basically holds all the database configuration. Yeah, all the database configuration, as we don't have to access to the server. Like when we install database, so basically there are some configuration file of the database. Like in MySQL, we have my.cnf file, which we modify to tune the database. So that file access we don't have in RDS because we cannot log into the database server. So here that part is basically managed by parameter group.
Okay.
Yeah, now the same concept we have is of option group. Option group is basically more for integration. Let's say we want to integrate our RDS database with Elastic Cache, okay, or any caching service, which basically improves the performance of the database. Okay, in that case, basically we use option group. And the same concept applies here also, that we cannot modify the default option group. When we create the database, so by default, the default option group is attached to the database server. Okay, and of the default default option group, we cannot make any changes. Okay, even here we don't have in the default option group, we don't have any settings. Okay, so here also what we do, we create a custom option group and we configure the option group with some settings, some options. Let's say this is for memcache integration. Okay, this is for additional, I would say it's more for integration. Okay, and here also we cannot modify the default option group. We have to create a custom option group and attach the option group to the database instance. Okay, custom availability zone is not a part of certification exam, and it is also introduced, I would say, last year, which is like creating availability zone inside of our on-premise data center. Like our on-premise data center will be acting um, as availability zone for AWS. So then we can run one. We can run a like the standby database in our on-premises also. Okay, which will basically exclude the multi-agent deployment cost. Okay, let's say we are deploying a very big database, so it will one database itself will cost $1,000 for a month. And if we are deploying it in multi-agent deployment, so it will cost charge us $2,000 a month. Right. So instead of that, if we have servers on premises, so we can use one server. I mean, we can deploy the primary database. I would say the secondary database in the standby database in the on-prem environment. Then here in events, we can see all the database events. Oops. Okay, all the updates related to all the events related to the database, like when the snapshot was created, when the when any upgrades were applied on the database. So those things basically we can see here. Then we have certificate updates. So this RDS database basically uses a certificate, and that certificate is basically used for that we can use. Actually, by default, it is not enforced. Like when we connect to the database, so the connection is established in with no SSL. Okay, no SSL, it means like our connection to the database is not encrypted. Okay, if we want to encrypt the connection between the server and the client, so in that case we use SSL certificates. Okay, in that case we use SSL certificates. Okay, this was one warning generated long back by AWS, which was like their SSL certificate was expiring. Actually, AWS itself generates a SSL certificate for us, which is the region specific. Okay, so far, do you have any other question?
No.
Okay, okay, sounds good. Okay, now let us talk about another concept of RDS, which is read replica. Okay, which is RDS read replica. So let's say we have created our database server, and this database is running in Virginia. And let's say we have customers all over the globe. Okay, let's say we have customers in Australia, UK, Africa, Brazil. We have customers all over the globe. Now, if we have customers all over the globe, let's say this database is in Virginia and someone from Australia is trying to connect to the database. So in that case, there will be a latency issue, right? There will be a latency issue. Let's say we have, let's say this is the this is US region, and here we have that database server running. And someone from Australia is trying to connect to the database. Okay, let's say if someone from US itself is trying to connect to the database, let us see, let's compare the latency. So let's say if someone from US itself is trying to connect, so the latency will be in milliseconds. Okay, it will be, let's say 10 to or 20 milliseconds. Okay, which is very less. And the same, if someone from Australia is trying to connect, it may take, let's say 500 millisecond. Okay, or maybe more than 500 millisecond to connect to the database. Okay, or to get a response from the database. Right? 500 millisecond means almost half second. Right? Almost, almost half second. Okay, which is very, if we talk in terms of, this sounds very low, like half second, but if we talk in terms of when the user is accessing the application, so half second delay is a lot, right? Now to overcome this problem, basically we have the concept of read replica. Now with read replica, what we can do is, instead of having the data, like instead of the user to connect, let's say the user to from Australia to connect to the primary database, which is in US, the user can directly spin up a database. I mean, with the read replica, we can directly spin up the database in that country itself or that region itself. Now let's say if you have customers in UK, so we'll deploy one read replica here as well. So instead of request going to this server, it will now go to this server, and the latency will be very less. Okay, the latency will be very less. Now, the reason why we call it as read replica is, replica is fine. Okay, replica, it means it's just a clone of that database. Okay, this is the primary database, and these databases are clone of that database. Hence, we are calling it as the replica. But why we are calling it as read? The reason we are calling it as read replica is, all of these databases will be replica, but on these databases we can only perform read operation. Okay, we can only perform a read operation in these databases. We cannot perform write operation. Only inside the primary database we can perform read write operation. And on these databases we can only perform read operations. Okay, on the read replicas we can only perform read operations, whereas in the master database, okay, let's say we have created the master database in Virginia. So of this database, on this database we can perform both read and write operation, whereas for the read replicas we can only perform read operations. Okay, read operation, which means it will only be able to query the data. Let's say if it wants to insert the data, then it has to go to the primary database. Okay, and all these databases are in synchronization, which means any data which is created here will be replicated here and here. Okay, and this is also done in few milliseconds. Okay, not few milliseconds, 100, 200. There is a lag of 100, 200 millisecond depending on where we have created the read replica. But once the data is created, it is immediately replicated across. It is immediately sent to be replicated across other databases. Okay, and the replication mechanism used here is asynchronous replication. Whereas in multi-easy deployment, we have synchronous replication. And here we have asynchronous replication. Okay, here in read replicas, we have asynchronous replication. Whereas in multi-easy deployment, we have synchronous replication. Okay, do you have any questions about read replica?
Yes, so for the advantage there, is it that the read replicas, do they cost less to spin up than the primary?
In terms of cost, it is almost like here we have created two databases, right? Let's say one in UK and one in Australia. So in terms of cost, it will be expensive only. But if we talk in terms of performance, in terms of disaster recovery, in terms of disaster recovery, so this is the best solution, like creating the databases across multiple regions. Okay, in that way we will achieve high availability, low latency, right? And yeah, we'll be achieving high availability, low latency, and disaster recovery. Let's say if the primary database fails, we'll be having the same clone, same replica of the database in some other regions as well. Okay, so the chances of failure will be very less.
Okay, so if the primary fails, then which read replica takes over? Is that something that you designate?
Yeah, if the first one fails, so it will automatically fail over to the first read replica. I mean the first read replica, which was the replica which was created first. So let's say if we created the read replica first in Ohio, so it will be replicated to Ohio region.
Okay, and
become active. Ohio region will become active.
okay, and then I think I missed your answer to, is it additional cost? It's an additional cost for each read replica, is that correct?
Yeah, there is additional cost. Yeah.
Okay, but it's not as much as the primary, like it's not the same since the primary has the read write function?
Yes.
Okay.
Yes, exactly. Yeah, primary has the read write and others have only read operations. They support read operations.
So if on the exam it asks which deployment option is better for high availability, aren't they both? I mean, which one would be better? Aren't they both good for high availability?
Yeah, in terms of one region, if you are talking just in terms of one region, so in terms of that, multi-easy deployment is much better. Okay, if we talk in terms of one region, if we are talking about multi-region deployment, in that case, see, basically read replica is more for disaster recovery, whereas multi-easy deployment is for read replica is more for disaster recovery and scalability. Okay, whereas multi-easy deployment is more for high availability and failover. Okay, it is more for I mean, it's more for high availability and failover. Actually, we can get this. There is one differentiation table which AWS has posted in one of their IPAC versus read replica. This is not. Yeah, also there are limits, like we can only create 5 read replicas in a region for a database. Yeah, here you can see multi-easy deployment, multi-region, and read replicas. So multi-easy deployment, the main purpose is high availability, whereas read replica, the main purpose is scalability. And if you are doing multi-region deployment anyway is read replica. Okay, we are indirectly calling read replica as multi-region region deployment here. So the main purpose is disaster recovery and local performance. Okay, low latency we can say. Non-Aurora is synchronous replication. I mean the replication mechanism used in multi-agent deployment for non-Aurora database. Okay, now this term you will also see in the certification exam, non-Aurora. So non-Aurora are the databases which are not Amazon Aurora database. Okay, like if we see here when we create the database, so whenever we see non-Aurora, so non-Aurora databases are these 5 database engines. Non-Aurora databases are these 5 database engines like MySQL, MariaDB. So whenever we see non-Aurora, so basically we are talking about these 5 database engines. So for non-Aurora database, the synchronization is, the replication is synchronous replication. Whereas for Aurora databases, the synchronous replication is asynchronous replication. Okay, for multi-region deployment or read replica, it is asynchronous replication for both. Okay, so read replica follows asynchronous replication, whereas multi-agent deployment for non-Aurora databases synchronous replication, whereas for Aurora it is asynchronous replication. Then non-Aurora, only the primary database is active, whereas in Aurora all instances are active. Okay, few features of Aurora are different. Okay, I'll send you this link.
Thank you.
Okay, I just shared it on the chat. Okay, all read replicas are accessible and can be used for read scaling. All regions are accessible and can be used for reads. Automated backups can be enabled. Whereas in read replica, no backup configured by default. Automated backups are taken by standby in non-Aurora, whereas in Aurora, automated taken by shared storage layer. Okay, it can span across at least 2 availability zone within a single region. Each region can have multi-easy deployment. Okay, and these read replicas also we can enable multi-easy deployment, which means it will be having one more database, one more standby database. Okay, in these read replicas we can enable multi-easy deployments. Database engine version upgrades happen on primary. All instances are upgraded together. This is more about maintenance window. Database engine workdate is implemented in each region. Aurora, all instances are updated together. Database engine version is independent from source instance. Aurora, all instances are updated together. Automatically fail over to standby for non-Aurora. or read replica. Read replica Aurora when a problem is detected. Or Aurora allows promotion of secondary region to be master. Now also one more thing which we can do, let's say when we have created this database, a read replica database, and later what we want to do is we want to make this database as the leader. Okay, leader, I mean, we want this database to have read and write operation both. Okay, we want this database to now have read and write operations both. Okay, so we can promote this database, we can promote this read replica as a master database, okay, or I would say as an instance. Okay, once we do that, then this database will be out of the cluster. Okay, currently the database in read replica mode, it will be inside the cluster. Okay, inside the cluster, it means all the database will be in sync. And once we make it as an instance, so this database will no longer in sync. Then it will be like something like this. And this database will be outside of the cluster. It will not perform any syncing. I mean, it will not, any data which is created here will not be replicated here. Okay, once we move it outside the cluster. When we, so that process is basically called promoting a read replica. Okay, and that's what this last point is talking about. Aurora allow promotion of secondary region to be the master. Automatic failover can be manually promoted to a standalone database instance. Non-Aurora to be primary instance. Yeah, so these are some of the differences. And also there is one more difference, like for a non-Aurora database, I mean, these databases, we can create up to 5 read replicas. We can create up to 5 read replicas. Whereas for the Aurora database, we can create up to 15 read replicas. Okay, which is almost thrice of non-Aurora database, right? So in Aurora database, we can create 15 replicas, whereas in non-Aurora database, we can create 5 read replicas. Okay. Also in non-Aurora database, okay, in non-Aurora database, we have one type of deployment, which is where we set compute capacity. Compute capacity, which means the instance type. Instance type, which is T2.micro, T2.medium, that we set in non-Aurora database. Whereas in Aurora database, there are 2 types of deployment. One is with compute capacity and one is serverless. Okay, one is with compute capacity and one is serverless. Okay, if we are deploying the database with compute capacity, so it is same, like we have to just choose the instance type. Okay, we have to just choose the instance type. But if we deploy it in serverless mode, Okay, so it's a very cool feature. In serverless mode, basically we can set minimum resources and maximum resources. Okay, we can set minimum and maximum resources in serverless mode, which means we can set, like we want to create the database instance with the 2-core CPU and 4 GB RAM. And if there is a lot of let's say 90% of resource utilized, then expand it to 4 GB and 16 core expand it to 4 CPU and 16 GB RAM. Okay, so basically we set the minimum and maximum resources required. We set a limit here. And when these resources are being utilized, after that, it will automatically scale up to this resource, these resources. Okay, this is, we can say it is more similar to storage auto scaling feature. Like when the storage is 90% utilized, it will automatically bump up the storage, right? The same way in Aurora database, this is only supported in Aurora database, and if the deployment is serverless deployment, then only this feature is supported. Okay, in the console, when we create Aurora database, so first we have to choose which kind of database we want to create. One is MySQL or Postgres, okay, depending on our application use case. And then capacity type. Okay, capacity type one is provision. Provision is basically here in which we have to choose the instance type. The DB class we have to choose manually, like t2.micro or what, which instance class we want to choose. And this is defined. Okay, this is defined, which means when our database will be created, it will be only using that much amount of resources. It will not scale up. If there would be more CPU utilization, it will not scale up. But if we are using Amazon Aurora with serverless, okay, this feature we only have in serverless mode only. This feature we don't have in provision. We only have this feature in serverless. If we are using the Amazon Aurora serverless, so here we have to set the capacity unit. Let's say we want 1 core CPU and 2 GB RAM, and when 90% of resources will be utilized, we want to scale it up to, let's say 4 core CPU, 8 GB of RAM. So these things we can do using Amazon Aurora. This thing we cannot achieve using non-Aurora database. In non-Aurora database, we can only set a fixed size. We can only set a fixed size, like it will be consuming only 2 core CPU and 4 GB RAM. We can only set the fixed type. Whereas in serverless, we can set minimum resources and maximum resources, where it will automatically scale up. Okay, and here you can see some of the other advantages, like Amazon Aurora is SQL and MySQL compatible enterprise class database starting at less than $1 a day, up to 5 times the throughput of MySQL and 3 times the throughput of Postgres. This is basically comparison in terms of performance. In terms of throughput performance, it is much better as compared to MySQL. It is 5 times better than MySQL and 3 times better as compared to Postgres. Up to 65 TB of auto scaling SSD storage. So we can also auto scale the storage. Oh, wow. We can auto scale it to 65 terabyte. Okay, whereas if we go with, let's say, if we go with non-Aurora database, okay, if we go with a non-Aurora database, so the disk size cannot be exceeded more than 16 terabytes. Okay, for a non-Aurora database, it cannot be exceeded more than 16 terabyte. Whereas for Amazon Aurora, yeah, whereas for a non-Aurora database, whereas for Amazon Aurora, it can scale up to 64 terabytes. Okay, and for MySQL, MariaDB, Postgres, it cannot scale more than 16 terabyte. If we have to store a lot of data, so in that case, we can go with Amazon Aurora. And it also offers 6-way replication across 3 availability zones. When we create multi-AZ deployment for read replica, so it also has more replication zones. Okay, let's say we create provisioned one. Yeah, create a read or create an Aurora replica or reader node in a different availability zone, and it is recommended for production scaled availability. Creates an or yeah. So this is the same concept, but it replicates across multiple availability zone, whereas a non-Aurora replicates only for a one availability zone. And on a read replica, we can create up to 15 read replica. Sorry, for Amazon Aurora, we can create up to 15 read replicas with an latency of 10 milliseconds. Okay, which is very less. Then automatic monitoring and failover in less than 15, less than 30 seconds. Which means, let's say if your application get down, if your database got down, so it will automatically replicate. It will start redirecting the traffic to the standby database within 30 seconds. Okay, so these are some of the advantages of using read replica. Okay, as compared to other SQL databases. Do you have any questions still here?
I can't just send you.
Let's see.
Yeah, you can get some.
I
But
don't
if you
think
want-
so. Well, okay, so the multi-AZ for Aurora. This is their
Sorry. Hello.
Hi, did you hear my question?
No. I think your voice. Yeah,
Oh,
was not
sorry.
clear.
Yeah, my connection is a little spotty right now, but I was wondering if the 15 replicas are automatically deployed when you choose multi-AZ with Aurora.
No. We have to manually deploy it.
Okay.
Okay, so we are good with RDS now. Now we'll start with the VPC service of AWS. Okay, in the certification, the questions will be more about the read replicas and the multi-AZ deployment, and they may ask some differences between Aurora database and a non-Aurora database, as we discussed here, and yeah, they may ask the replication which is supported in what replication is used in multi-AZ deployment, what replication mechanism is used in read replicas, what are the different types of database engines are supported in RDS. Okay, and some scenario-based questions also they may give, like if a company wants to host a database service, and I mean they want to host a database for their front-end application, so what service they should choose, and yeah, like they will be giving some scenario-based question for database. There will be 4 to 5 questions at least in the certification exam for RDS. Okay, actually more than 4 to 5 questions. 7, 8 questions at least will be there in the certification exam related to RDS. Okay, and to create a read replica, we can, once the database is ready, and we can just click on create read replica. And it will basically ask a region in which region we want to deploy the read replica database. Okay, and it will take at least 50-20 minutes to provision. Let's say, depending on which region we are deploying. Okay, so here you have to choose the source database, and this will be the read replica database name and which region we want to deploy. And if you want to change the database class, that also we can do. Almost all the configuration we can do of the read replica database as well. Okay, and deleted, we can just click on delete, but we will not be able to delete it. And the reason is we have enabled deletion protection on the database, right? So for that, you have to modify the instance and we have to disable the deletion protection. Okay, deletion protection is basically for preventing accidental termination of our database server. scroll all over down, we have to disable this. And as this instance is deployed in production mode, and hence it is basically asking us to whether we want to apply these changes in the maintenance window or immediately. So we'll go with immediately. Then we'll just delete the database instance. And here we have to type delete me. Okay, now we'll be talking about VPC service of AWS. Do you have any idea about VPC?
Yeah, so it's the virtual private cloud. It's where all of your services are located.
Yeah. Do you have any understanding about networking?
Maybe a general understanding as far as having a gateway open to the internet and being able to access that, and then having routing tables in place to direct the traffic, and yeah, so I have a general idea.
Mm-hmm. Okay. Okay, yeah, actually, VPC is something which is actually similar to on-premise network. Okay, which is similar to on-premise network. Okay, like in the cloud, like in on-premise, let's say if you're working, let's say in all the companies, actually we have one router. Okay, we have one router. Do you know what is a router?
Not really, I guess.
Yeah, okay, so a router is basically a networking device through which basically we connect two different networks. The main use of router is to connect two different networks. Okay, and with router we can router also act as a gateway through which we connect to the internet. Okay, right now we are connected to the internet because of router only. Okay, like at my home I have let's say a router, physical router, and at your end you may have a router through which you are connected to the internet. Okay, routers could be wired also and wireless also. Okay, wireless is like when we connect our laptop with the Wi-Fi, so that is basically a wireless router. Okay, yeah, so basically we have a router and the on-premise, and we have switch. Okay, switch is also a hardware device. Okay, the purpose of switch is different as compared to router. Okay, so in switch basically we have, let's say we have two computers. Let's say we want these two computers to connect with each other. So we connect it with a LAN cable, right? We connect both the computers with the LAN cable, right? Are you familiar with LAN cable? Yeah, this is how basically it looks like. Shopping images.
I tasted it. Yeah. So I just
Yeah, this is how
garlic.
And this
basically
is,
it looks
you
like.
said it goes, and it
Huh?
goes in computers or, okay.
Yeah, cat cables, cat cables. It's also called cat cable. Tyler, I think from your end there is some maybe internet lag. I think I can hear you, but your voice is little breaking, or maybe the same you may be also facing at your end. I mean, you may be hearing me only half.
Sometimes there's lag and then,
Yeah, your voice is breaking a lot.
catch
actually.
up kind of.
Sorry.
Okay.
Well,
Yeah, my internet connection isn't super strong right now, but I think I'm getting most of what you're.
Mhm. Okay, okay, okay. So to connect to computers, we have two LAN cables. Okay, and with these two LAN cables, we have one LAN cable. With this LAN cable, we connect two computers. Now let's say we have three computers. Now to connect three computers together, we need, we cannot do that. Okay, we need to then attach a network interface card in both the computers, extra network interface cards. Okay, to do that. But instead of doing it with NIC cards, what we do, we use switch. Okay, we use a network switch, and instead of connecting it with LAN cables, like computers with each other, we connect the LAN cables with switch, and with switch, multiple computers can connect to each other. Multiple computers can connect to the switch, and the switch is connected to the router, and router is again connected to another switch, and in this switch we have more computers. Okay, here again we have more computers which are connected with the switch. Okay, which are again connected to the switch, and then switch is connected to the router. And because of this network architecture, these computers are able to connect to each other. Okay, these computers can talk to this computer. This computer can talk to this computer. This computer can talk to this computer. This computer can talk to this computer, which means all the computers are in network. If they are not in network, they will not be able to talk with each other. And if they will not be able to talk with each other, so let's say if you have one web application and you want to connect it to the database, and let's say both the servers are not able to talk to each other, so the database will not be able to connect to it. I mean, the front end web server will not be able to connect to it. Okay, so network connectivity is very much important. Okay, if we don't have proper connectivity, then things will not work. Okay, so the same architecture we have in the cloud. Okay, so the router which we are seeing in the cloud, we are calling that router as a VPC. And then we have these switches. In the cloud, we are calling these switches as subnets. Okay, in the cloud, we are calling these switches as subnets. And then we are calling these computers as our EC2 instances. There is basically a lot of layers where we have the EC2 instances, where we have the subnets, we have the VPC. So this will be VPC. In the cloud terminology, router is basically the VPC. The switch is the subnet, and these hosts are basically the EC2 instances. Okay, it can be EC2 instances. It could be RDS instance. RDS instance is also created inside a VPC. Okay, and a lot of other resources are basically created inside a VPC. Okay, now if we go to the console, so when we set up when we create an AWS account, so AWS on our behalf basically creates VPCs in all the regions. Okay, AWS creates VPC in all the region, which is also called default VPC. Okay, it is also called a default VPC. And this default VPC has subnets in all the availability zones. One subnet in each of the availability zone, right? Let's say we have a let's say in this region is Tokyo, and in Tokyo we have 3 availability zones, right? In Tokyo we have 3 availability zones. Now if we go to subnets, now if we go to subnets, so here we can see 3 subnets, right? We can see 3 subnets, and if you see this availability zone of these subnets, so each of them are created in one availability zone. Like this, the first one is created in A, second one is in C, and the fourth one is in, third one is in D. Okay, actually in this region, one availability zone is not active. So hence it is showing A, B, and D. Sorry, A, C, and D. D is not active currently. Hence it is showing 3 availability zones. Okay, it may be down, or it may be used for some other purpose, like for government. Okay, like for the US government also we have the Gov Cloud, AWS Gov Cloud, which is only used by the US government. Okay, same way here also we have this this AP South 1B, which is used for the internal purpose. Okay, so here we can see each of the availability zones have a subnet, right? Each of the availability zones have a unique, each of these subnets are residing in a availability zone. So in the certification exam, there could be some like ask few characteristics of the default VPC. The first thing which can be asked in the certification exam is what is the default CIDR of the default VPC? What is the CIDR of default VPC? This is one question which can be asked in the certification exam. So the default CIDR of VPC is this 172.31.0.0/16. Okay, so you have to remember this, that the default CIDR is this. And in all the regions, the CIDR range is the same. If we go to any other region also, the default CIDR of the default VPC is the same. Okay, this is the IP address range. Okay, this is the IP address range in which this we can also call it as the router IP address. Okay, and if we go to subnets, so in each of the availability zones, we have one subnet in the default VPC. Okay. Also, like in on-premise, we used to have a gateway through which our router connects to the internet, right? And through that, our switches and our host computers connect to the internet. The same way here in AWS, we have the concept of internet gateway. You have the concept of internet gateway. And with internet gateway, we can create instances. Oh, sorry, we can access the internet in our EC2 instances. Right? So right now the instance, the data which we access, the internet which we access in our EC2 instance, that we basically access based on this internet gateway only. If we don't have internet gateway in our VPC, then we will not be able to connect to the internet. Okay, we will not be able to connect to the internet. Then we have route tables. Okay, route tables are like in router we have routing tables. Okay, and in routing table basically tells which network can talk with which network. Okay, yeah, this is how basically a routing table look like. Okay, here you can see the destination and gateway. So the same kind of routing table basically we create in AWS, which is this. And in that basically we have the routes. This is basically the table. Okay, here you can see destination and the source, which is basically the target. We are calling it as target. So the same concept we have here as well. Then we have the concept of MACL. Okay, there are 5 main things in the VPC. Like one is Group tables, subnets, internet gateway, NACL. Okay, and one is NAT gateway. Okay, NAT gateway we'll be talking about that later when we'll be talking about the concept of public and private subnet. Okay, then we have NACL. NACL is basically used for, it basically stands for Network Access Control List. And with NACL, basically we can create rules. Okay, we can create rules. Okay, like it's similar to firewall rules only. Okay, the security group rules which we create, that only basically we create in NACL. Okay, but the difference is in security group we can only create allow rules, whereas here in NACL we can also create deny rules. Okay, later when we look exploring more about VPC, then we'll be creating our own VPC. At that time we'll see some more differences between NACL and security group. Do you have any questions still here?
Yes, you might have mentioned this, but so other than the fact that you can allow or deny with NACLs, what is the other difference between security group? Like, why are there two different services here? Like, why is there security group and a NACL?
The security group basically works at the instance level, whereas NACL works at the subnet level. Here NACL we do not associate to an instance. NACL we associate to a subnet, and all the instances which are inside that subnet will be inheriting the rules which the NACL has. Okay.
Okay, so so the traffic from the internet would come in through the internet gateway, go to the routing tables, and then it would hit the NACL before the subnet. So it would have to pass through it would have to meet these conditions or these rules before it could access the subnet.
Yeah, exactly.
Okay, and then the subnet, after it accesses the subnet, it then tries to access the security group to get to the instance, or is that?
Sorry.
Is that the flow?
Yeah, first it comes through the internet gateway, then it goes through NACL. From NACL it goes to subnet. From subnet it goes to security group, and from security group it goes to instance.
Okay, thanks.